Hello and welcome to the video on machine learning introduction. In this video, hello and welcome to the video on supervised machine learning. In this video, I'll teach you the basics of supervised machine learning and how it works. So, supervised learning is a type of machine learning in which machines are trained using the labeled training data, and on the basis of that data, machines predict the output. So, the labeled data means some input is already tagged with the correct output. In supervised learning, the training data provided to the machines work as a supervisor that teaches the machine to predict the output correctly. That's why the name supervised learning comes. It applies the same concept as a student learns in the supervision of a teacher. Now, supervised learning is a process of providing input data as well as correct output data to the machine learning model. The aim of a supervised algorithm is to find a mapping function to map the input variable x with the output variable y. Some real world examples of the supervised machine learning can be risk assessment, image classification, fraud detection, spam, mail filtering, etc. etc. So, I'll make you understand in a better way with the help of this diagram. So, this is the entire life cycle of a supervised machine learning project. So here is your machine learning model. Now we want to train this model with the help of some labeled data. Let's say we are having a data set that contains images of three different type of shapes. The first one is hexagon, the second is triangle, and the third is square. So what will we do? Let's say this data set has 100 entries. So we will use 70 entries and each of them will be labeled. So all the 70 entries, all the 70 rows that will be given to the input to the machine learning model for training will be labeled. So this will be known as hexagon, this is hexagon, this is square, this is square, this is triangle. So this all 70 rows will be given to the model for training. Then once the model is trained on the training data, then what we'll do, the test data, that was the remaining 30%, or in this case the remaining 30 rows of the data set, then we'll give those 30 rows to the model for prediction. Now these 30 rows will not have the labeled attached to the picture. So this in the test data only this picture will be given as the input to the model, and based on the patterns that the model has extracted from this training data, it will predict that this is the picture of a hexagon, this is a square, and this is a triangle. So if I want to explain you with the help of this picture, so here we are giving the labeled data for model training. These are the labels. Now once the model is trained, we want to predict the output on the test data. Now if you have a look on this data set very carefully, we don't have labeled data. This is just an image of a square and a triangle. We are not labeling them. So the model will correctly predict that it is square and it is triangle based on the patterns that it has derived from this training data. So this is how supervised machine learning works. Now again, supervised machine learning can be further classified into two subcategory of problems. So in supervised machine learning, mostly we'll be dealing with regression type of problems and classification type of problems. So the problems in which we want to predict a certain numerical value. Let's say we are having the IQ of a student, we are having the CGPA of the students, we are having the high school mark sheet of the student, and based on these numbers, we want to predict the next year CGPA of the student. So this, as we are trying to predict a particular number, that is the CGPA, so in such numerical case, we call it a regression problem. And the classification problem will be like, let's say you are having the IQ of the student, you are having the CGPA of the student, you are having the mark sheet of the student. Now you want to predict that whether the student will get a job in campus placement or not. So getting a job or not. So there are two categories that in which we want to classify the student. So this is how the classification problem works in supervised machine learning. So I hope you are very clear with supervised machine learning. This is the entire life cycle of the supervised machine learning, and these are the two different types of problems that we are going to deal in supervised machine learning. So let's move to the next video. Thank you. I'll introduce you to the basics of machine learning. We'll learn about different types of machine learning, and I'll try to give you some roadmap of how we are going to cover machine learning in the next few videos of the course. So let us start. First of all, let us formally define what is machine learning. So machine learning is said as a subset of artificial intelligence that is mainly concerned with the development of algorithms which allow a computer to learn from the data and past experiences on their own. The term machine learning was first introduced by Arthur Samuel in 1959. In a summarized way, machine learning can be simply said that it enables a machine to automatically learn from data, improve from past experiences, and predict things without being explicitly programmed. So, this is how you can define machine learning formally. Now, let us try to understand with the help of this picture. So, a human usually can learn automatically from his or her own experiences. Here, the machine also says the same thing. I can also learn from the past data with the help of machine learning. So, up till now, whatever we have covered in the data science or data cleaning portion, so we were having a CSV data set. Now, we were doing all the data pre-processing and data cleaning steps on that data set. Now the cleaned data will be given as the input to a machine learning model, and all the analysis and predictions will be done by the machine learning model. So this is the life cycle. This is the entire life cycle of a data science or a ML project. Now, with the help of some sample historical data, which is known as the training data, machine learning algorithms build a mathematical model that helps in making predictions or decisions without being explicitly programmed. Machine learning brings computer science and statistics together for creating predictive models. Machine learning constructs or uses the algorithms that learn from historical data. The more information we provide, the performance will be better. A machine has the ability to learn if it can improve its performance by gaining more data. So, we train the machine learning model on some sample training data, that is the historical data that we have. Now, once the model is trained on the training data, we can use new data sets on the same model to predict the output. So, this is the life cycle. So, input past data will be given as training to the machine learning algorithm. This machine learning algorithm will learn and extract patterns from that data, and it will, based on the patterns extracted and the learnings from the training data, it will build some logical models or patterns. The ML algorithm will build that. Now, once we have a ready trained model, the ML model, now what we'll do, we will give new data to that model and then we'll predict the output. I'll tell you a real life case study of the machine learning process. So let's say we are having 5 different images, or we are having some different images, and the images can be of an apple or an orange. So what we do, we have a, let's say, a machine learning model ABC. Now we'll give or we'll train the machine learning model ABC on hundreds or let's say 1000 of images. The 1000 images that we're giving as training sample to the model will have the images of both orange and apple. So let's say the machine learning model will try to derive features of apple and oranges. Let's say from an image of an orange, the model derives some features like it is round in shape and it is of orange color. And from the image of apple, the machine learning model extracts the feature like it is of red or green color. So based on the learnings that the model has derived from the training data set, the sample of 1000 images that we gave to the model, it will store all those learnings and create a specific pattern inside it. And if you give a new image to the same trained model, now the model will be able to classify it between apple and orange. So this is how the life cycle of a ML project works. Now, after saying that, let us discuss the different types of machine learning that we are going to study. So first of all, we have the supervised machine learning, then we have unsupervised machine learning, and then we have the reinforcement learning. For the scope of this course, we are going to cover these two in detail. So supervised and unsupervised. Supervised machine learning can be further be classified into classification and regression problems, and unsupervised learning can be also known as the clustering or segmentation problems. So in regression, basically we try to predict the numerical value. Let's say you are having the features of you are having different attributes about student, his IQ, his age, his CGPA, and you are trying to predict the salary of the student. So that is a numerical value that you are trying to predict. So that will fall under supervised learning, and even in supervised learning we can call it a regression problem. And the apple orange example that I gave you can be called as the classification problem. So we are trying to classify the images into apple or orange. Now moving on to unsupervised learning, In unsupervised learning, a very good example can be clustering algorithms. For example, a retail store wants to cluster its customer into different groups based on the credit score, salary, income, spending habits, gender, etc. etc. So it will create different clusters of the customer. So in cluster one, let's say we are having those customers, they have a very high tendency to spend. So the store will pitch more high-end products to that particular customer. And let's say in cluster 3 we are having different kind of we are having some kind of customers that don't spend very much, so the store will offer more discount or something like that to the customers that are present in cluster 3. So these are the types of machine learning that we are going to cover in detail in the next few videos. So I hope you are very clear with the basics and introduction of the machine learning that I gave you in this video. Now let's move to the next video. Thank you. Hello and welcome to the video on unsupervised machine learning. In this video, I'll tell you about the basics of unsupervised machine learning. So let us start. First of all, what is unsupervised machine learning? As the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training dataset. Instead, models itself find the hidden patterns and insights from the given data. It can be compared to learning which takes place in human brain while learning new things. So formally, unsupervised learning can be defined as that it is a type of machine learning in which models are trained using unlabeled dataset and are allowed to act on that data without any supervision. Now, unsupervised learning cannot be directly applied to a regression or a classification problem unlike we saw in the supervised ML. But we have the input data and no corresponding output data. So the goal of unsupervised learning is to find the underlying structure of the dataset, group that data according to the similarities, and represent that dataset in a compressed format. Now, have a look at this example, and the concept of unsupervised learning will be very clear to you. So now here you have this model, and we won't train the model using the training dataset that we discussed in the supervised learning, that we keep 70% or let's say 80% data for training. We use that data to train the model and then we test the model on the remaining 20% of the data. That we don't follow here. We'll give the entire raw input data to the model without explicitly being trained. The model will extract certain patterns from these unlabeled data points, and it will automatically categorize these data points into different categories or the segmentation it will perform. So here, based on the features extracted from the data, the model automatically clustered the images into dogs and cats. So this is also known as a clustering problem. Will cluster similar type of images together. So in cluster 1 we are having all the images that have dogs, and in cluster 2 we are having all the images that have cats. So here we are not performing the label data part or the training data set that we used to do in the classification algorithm or the supervised machine learning algorithms. Now, unsupervised learning can be further be divided into two more sub problems. The first one is what we call the clustering problem, the example that we saw in the previous slide. This is a clustering problem. The second problem that we solve is the association problem, or a very famous example for this association is the market basket analysis. All these two problems we'll see in detail in the next few videos, but for the part of this video you should be very clear with the difference of supervised and unsupervised machine learning and the entire life cycle of a unsupervised machine learning project. So I hope you're very clear with all the concepts that we discussed in this video. Now let's move to the next video. Thank you. So these are the various stages that are involved in a complete machine learning project. You first gather the data or data collection or data acquisition step. Then you have data preparation or data wrangling, data analysis. So this is all data pre-processing steps. And then based on the data that you have analyzed and cleaned, you train a machine learning model. And once you are satisfied with the performance of the machine learning model based on the predictions that it is making, after testing you use that model into the deployment or production. So this is the basic overview of a complete machine learning life cycle. Now let's understand each step in detail. Data gathering is first step of the machine learning life cycle. The goal of this step is to identify and obtain all data related problems. In this step, we need to identify the different data sources, as data can be collected from various sources such as files, database, internet, or mobile devices. So you can either have a ready-made CSV file, or you will be extracting data or from a database, or you will be scraping data from the web. So these are different sources of the data. It is one of the most important steps of the life cycle. The quantity and the quality of data collected will determine the efficiency of the output. The more will be the data, the more accurate will be the prediction of your model. So this step includes different tasks like identify various data sources from where we want to collect our data. Then we have to collect the data from that sources, integrate the data obtained from different sources. By performing the above tasks, we will get the coherent set of data, which is also known as the complete data set. Now, this complete data set that we have used to acquire the data, this will be used in the further steps. Data exploration, it is used to understand the nature of data that we have to work with. We need to understand the characteristics, format, and quality of data. A better understanding of data leads to an effective outcome. In this, we generally find correlation, general trends of the data, and outliers if there are any outliers present in the data. Data pre-processing. Now the next step is pre-processing for this data that we have explored. We have tested the quality of the data. We are trying to identify different trends and patterns from the data, cleaning it, finding outliers, and then it is ready for pre-processing. Now it is not necessary that the data we have collected is always of our use, as some of the data may not be useful. So in real world applications, collected data may have various issues, including the data may contain some missing values, or there may be redundant or duplicate values in the data. Then some invalid or non-relevant data will be present in our data set. And finally, the data set will also have noise apart from the main crucial data that we want to work with. Now this clean data and prepared data is ready to pass on the analysis step. This step involves selection of different analytical techniques, building models, and will review the result. The aim of this step is to build a machine learning model to analyze the data using various analytical techniques and review the outcome. It starts with the determination of the type of problems, where we select the machine learning techniques such as classification, regression, cluster analysis or association, etc. And then build the model using prepared data, and then we evaluate the model. So we have to classify the type of problem or the business case that we are solving in combination of different ML problems, like whether it's a regression use case or it's a classification use case or it's an unsupervised learning like clustering or association. So based on that, we'll choose appropriate machine learning models to train. Next, we have model training, testing, and deployment. Once we are done with data preparation and analysis, the next step is to train the machine learning model with training data and test it using the testing data and evaluate it on different metrics like accuracy, precision, R2 score. So we have a separate video of on machine learning metrics, like how do you evaluate the performance of a model based on different machine learning use cases like classification or regression. We have different metrics to evaluate the performance of our model. Generally we use precision, accuracy, recall, all that for a classification use case, and R2 score, mean absolute error or mean squared error, for a regression problem. So based on these metrics, we evaluate the results and understand whether the machine learning model is performing satisfactorily or not. So once we are satisfied with the performance of the model, then we can go for the deployment. So this is the complete machine learning project life cycle. Data acquisition, data preparation or pre-processing. This includes data cleaning, removing outliers, or data analysis or general trend about the data. Then you train the model, then test and evaluate the model, and finally deployment. So this is the complete video on machine learning lifecycle. I hope you are clear with. Hello and welcome to the video on train test split in machine learning. So usually in supervised machine learning techniques, what we do, let's say our dataset contains 100 rows. So we'll train the model with 80% or 70% or let's say 75% of the data. So we'll split the dataset into two different parts. First will be the training part and second will be the testing part. So the model will learn or extract patterns, or you can simply call will train the model with the training portion of the data, that will be around 70 or 80% of the data. And then once the model is trained, we'll validate or test the model on the remaining 20% of the data that is still very new for the model. So after training the model, we'll give the unknown test data that we separated the 20% of the data after for validation purpose. So this is the use of train test split. As you can see, we have initially prepared our data, then we split the data into training part and testing part. The model will be trained, or the model will learn the patterns on training data, and then once it is trained, we'll give the test data, we'll evaluate the model and check whether what are the changes that need to be done. So train test split is a model validation procedure that allows you to simulate how a model would perform on new unseen data. Here is how the procedure works. So this is a full data set. Now these are all the features of the data set, and this is the target variable. We train test split, and this will consist of random sampling into training and testing sets. So this training portion will be used for training the model, and then once the model is trained, we'll give this test section and evaluate the model how it's performing. So the syntax from sklearn to perform the train test split operation is, from sklearn.model_selection we have to import the train test split, and then this is automatically inbuilt in the sklearn. So we have to write xtrain, xtest, ytrain and ytest. So xtrain and ytrain are the features and target of the training set, and xtest and ytest are the features and target of the test set. So we have to compulsorily maintain this order. First we have to write xtrain, then xtest, ytrain and ytest, then train underscore test underscore split, we have to call this, and then we have to pass the dependent and independent features. So our x will contain the dependent or the independent features, and y will be the target or the dependent features. Now random state, and then test train size. So here we are using train size is equal to 0.75. That is 75% of data will be used as training and remaining 25% will be used for testing. If we don't want to specify train size but we have to give the test size, then instead of train size we can write test underscore size, that will be equal to 0.25. So you can use train size or test size, depends upon you. So this was a little short concept that we are going to use in most of our supervised machine learning tutorials. Like if we study any algorithm like random forest decision tree, regression, etc, etc. So train test split is a compulsory step that will perform in the machine learning life cycle. So I hope you're clear with this concept. Now let's move to the next video. Thank you. The concept. Thank you for watching the video. Now let's move to the next video. Hello and welcome to the video on regression analysis. In this video, I'll teach you the basics of regression, and I'll also tell you about some important terms that we use very oftenly in the world of regression in machine learning. So, regression analysis in machine learning. Regression analysis is a statistical method to model the relationship between a dependent or a target variable and an independent or the predictor variables with one or more independent variable. More specifically, regression analysis helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. It predicts continuous real values such as temperature, age, salary, price, and etc. So whenever we are talking about regression, we will be talking about continuous values like temperature, salary, etc, etc. Now let us understand with the help of this example. Suppose there is a marketing company who does various advertisements every year and gets sales on that. The below list shows the advertisement made by the company in the last 5 years and the corresponding sales. So here we have 5 advertisements. So advertisement 1, $90 and sale was $1,000. Advertisement 2 is $120 and the sale is $1,300, and so on. Now the company wants to know or to do the advertisement of $200 in the year 2019, in this year. the company wants to do the advertisement of with the budget of $200 and wants to know the prediction about the sales of this year. So this we want to find. So to solve such type of prediction problems in machine learning, we use this regression analysis. So what we'll do, we'll train the model based on this entire data, and finally this data will be given as the input to the model at the time of prediction. So based on the patterns extracted from these data points during the training phase, the model will predict the sale value for this particular entry. I hope regression is very clear. Now some important terminologies related to regression analysis. Before deep diving into different regression algorithms that we're going to study in the course, you should be very clear with all these terminologies. So first one is a dependent variable. The main factor in regression analysis which we want to predict or understand is called a dependent variable or the target variable. So for this example, the sale will be a dependent or a target variable. Independent variable, the factors which affect the dependent variables on which are used to predict the values of dependent variable are called independent variables or the predicted. So the value of sale depends on the budget of the advertisement. So this will be the independent variable. The value of sale will depend on this one. So this will be dependent and this will be independent variable, or this is also known as the predictor. Now outliers. Outlier is an observation which contains either very low value or very high value in comparison to other observed values. Let's say in this example we have a entry with a budget of $1,000 and sales of only $20. So that will be considered as the outlier because the value is either very low or very high compared to the other observed values. So the point should be noted that an outlier may hamper the result, so outliers should be avoided. Now multicollinearity. If the independent variables are not highly correlated with each other than other variables, then such condition is called multicollinearity. It should be not present in the dataset because it creates a problem while ranking the most affecting variable. So due to this, you won't be able to find the most affecting variable or the variable that affects the target variable the most. Now underfitting and overfitting. If our algorithm works very well on the training dataset but does not perform well on the test, so when you're training the model, it is working very well, but at the time of testing you are not getting the desired output, then such problem is called overfitting. And if our algorithm does not perform well even during the training dataset, and such problem is called underfitting. So these were some important terms. Now these are some of the important regression algorithms that we're going to see in the course: linear regression, SVM, decision tree, random forest. So these are some types of regression algorithms. So I hope you are very clear with the basics of regression. Now let me introduce you to a concept of linear regression. So linear regression is a statistical regression method that is used for predictive analysis. It is one of the very simple and easy algorithm which works on regression and shows the relationship between continuous variables. So linear regression shows the linear relationship between independent variable x and dependent variable y-axis. So we will plot the independent variable on our x-axis and dependent variable will be on the y-axis, and we'll try to establish a linear relationship. Hence it is called a linear regression. If there is only one input variable x, then such linear regression is called simple linear regression. And if there are more than one input variables, then such regression will be called multilinear regression. So when we have more than one features on which the value of the target variable depends, then it is called multilinear regression. So the relationship between variables in the linear regression can be explained using the below image, and here we are predicting the salary of an employee based on the year of experience. So with the help of this image, the linear regression will be very clear to you. So on the y-axis we are trying to predict the salary, and we are trying to predict the salary based on the experience of that particular employee. So these are all the data points. So the employee with the experience of 2 years is having a salary of around 35,000. The employee with an experience of, let's say, 5.5 years is having the salary of about 50,000. So based on the trend that we are identifying from the given data points, we will try to establish a linear relationship. And let's say a new employee comes to us with the experience of around 9 years. So we'll plot that employee in the experience of around 9 years over here, and we'll say the salary will be around $110,000. So this is how linear regression works. We are basically trying to draw a simple equation of a straight line. Y is equals to ax plus b. So y will be a dependent or the target variable on the y-axis, and x will be our independent variables. A and B are basically the coefficients. This is very similar to the equation y is equals to mx plus c that you studied in the coordinate geometry in your high school mathematics. So if you are clear with that concept, linear regression will be very easy for you. So I hope you are clear with all the concepts that are discussed in this video. Thank you. Now let's move and welcome to the video on linear regression. In this video, I'll tell you about the linear regression algorithm in machine learning, and after the presentation and the theory portion is discussed, I'll also show you the practical implementation of linear regression algorithm with the help of sklearn in Python. So, linear regression is one of the easiest and the most popular machine learning algorithm. It is a statistical method that is used for predictive analysis. Linear regression makes prediction for continuous or numerical values such as sales, salary, age, product, price, etc. etc. Now, linear regression algorithm shows a linear relationship. It tries to establish a linear relationship between a dependent variable y with one or more independent variables x. Now, that's why, because it is trying to establish a linear relationship between the target and dependent features, that's why we call it a linear regression algorithm. Linear regression shows linear relationship, which means to find how the value of dependent variable is changing according to the change in the value of independent variable. The linear regression model shows or provides a sloped straight line representing the relationship between the variables. Consider these images. Now, here on the y-axis, we always have the dependent variable or the value that we are trying to predict, and on the x-axis, we have the independent variables. So these are all the data points, and this is the basically the line of linear regression that we are trying to plot. So if in case in future we get a new data point somewhere over here, then we can simply put or place it with the help of the line of linear regression and tell the value of the dependent variable or predict the output based on the independent features that we are getting for a new data point. Now let's understand positive linear relationship. If the dependent variable increases on the y-axis and the independent variable increases on the x-axis, then such a relationship is termed as positive linear relationship. So this is the image for positive line of linear regression. So the equation for this line we can be given as y is equals to a0 plus a1x. Now all the linear equations for a straight line that we learned in the high school can be derived from that equation, like y is equals to mx plus c. So m is the slope and c is the intercept. So here if we try to map that y is equals to mx plus c with this equation given over here, so a1 will be mapped to m and this a0 will be mapped to c. So the equation of the line becomes y is equals to mx plus c or y is equals to a0 plus a1x. Now this, clearly by seeing we can say that this is a positive slope of the line. Similarly, we can also have the negative slope here. So the equation, because this is a negative slope or negative line of regression, will have a negative value in the equation. Why do we get such negative line of regression? Because the dependent variable decreases on y-axis and the independent variable increases on the x-axis. So the value of x-axis increases but the value of y-axis keeps going down. That's why we get a negative linear relationship. Now let's move to the Jupyter notebook and try to implement the linear regression algorithm in sklearn. So let us start with the practical implementation of linear regression in Python. First of all, I'll import all the required libraries. So let me import numpy as np, import pandas as pd, and import. I'll also show you the visualization for linear regression. So for that I need matplotlib dot pyplot as plt. So these are all the required libraries. Now let me get the dataset into a pandas data frame. So pd dot read underscore csv, and I'll be using a salary data dot csv. And if I want to show you how the dataset looks like, so it says salary. Okay, I have made a spelling mistake. Now we have the salary data. So let us look how our dataset looks like. So here, this is the dataset. It has two columns, years of experience and salary. So the salary will be our target variable and years of experience will be our X fee or the independent feature. So based on the years of experience, we can decide the salary of that employee. Now, so let me split X and Y axis. So on the X, the independent feature will use dataset dot ilog. Here, what I'm going to do, I just want to select all the rows and only the values of years of experience, and Y will be my data set dot ilook. And here what I want to do is, okay, I forgot to put a comma over here. Now here what I want to do is dot values. So now I have my X and also here I have my Y. So these are X and Y for our machine learning model. Now what I'm going to do next, I'm going to split my dataset into train and test. So we'll use 70 or let's say 80% of the data for training, and then we'll evaluate or test the model on the remaining 20% of the data. So for that I need to include from sklearn dot model underscore selection import train test split, and then I want to make X train, then I have X test, then Y train and Y test, and I will call this train test split, and I want to make split on X and Y, and the test size I want to use only 20% of the data for test, and then I want to use the 80% of data for training. So this will import the train test split feature that sklearn gives us, and then will separate out the data from the entire data set. That's it. That is, we will keep 20% of the data for testing, and then we'll have the 80% of the data for training. So after doing all this, finally we'll import the linear regression model. So from sklearn dot linear model import linear regression. It will take some time to import the model, and now what I'm going to do, I'm going to make the instance of the model, let's say the regression object, and this will be of linear regression. So this is the regression object, and now I'll use the fit method. So we'll, to train the model on the training dataset, we use the fit model, and we want to train it on X train and Y train. So now we have a ready-made instance of the model. Now let's check the prediction of the test. So Y underscore pred will be equal to ridge dot predict. So this is the predict method that we are going to use, and here I'll write X test, and X pred will be equal to ridge dot predict, and here I have the X train. So these are the predictions. Now let's visualize all this. So for that I need to use matplotlib. So plt dot scatter, and here what I'm going to do, I'm going to plot X train and Y train, and let me plot this into green color. Now this will be the scatter plot. So these will be the data points, the training data points that we had in the training set. Now I want to also plot a line, the regression fit line from the X train and Y train. So X train, and I have X pred, and here the color of the line I want is red, and then plt dot show. So if I run this, now here I am having the years of experience on x-axis and the salary on the y-axis, and this is for the training data set. So let me also print something over here. So print, this is for training set. For training set we have this plot. Now let's also make the same plot for the test, that what we got from our linear regression output. So what I'll do, again I'll make a plt dot scatter. Inside the scatter plot, this time I'll have x test, and then I have the y test, and color will be, let's plot the data points in blue. Plt dot plot. Now here I have x train and x spread, and again color, the line I want is red, and plt dot show, and this is for testing data set, so test set. So this is how our linear model is working. We are actually getting a very good fit line that is able to predict the linear relationship between the number of years of experience and salary of the employee. So I hope you are very clear with the implementation of linear regression in Python. Now let's move to the next video. Thank you. Hello and welcome to the video on logistic regression. Logistic regression is one of the most popular classification algorithm, and in this video I'll teach you the math behind it and also show the practical implementation in SQL and Python. So let us start. Logistic regression is one of the most popular machine learning algorithms which comes under supervised learning technique. Now it is used for predicting the categorical dependent variable using a given set of independent variables. This statement is also true for other classification algorithms. Now logistic regression predicts the output of categorical dependent variable. Therefore, the outcome must be a categorical or a discrete value. It can either be a yes or no, or in mathematical terms we can say 0 or 1, or true or false, etc. But instead giving the exact 0 or 1, it gives the probabilistic value that lies between the range of 0 and 1. So this is the key point for logistic regression. Remember this statement and logistic regression will be very easy for you to understand. So logistic regression is much similar to the linear regression, except that how they are used. Linear regression is used for solving regression problems, while logistic regression is used for solving the classification problems. A lot of students are confused in the name of logistic regression. By the name they think that it will be a regression algorithm, but actually logistic regression is a classification algorithm. So remember this point. Now in logistic regression, instead of fitting a line that we used to do in the linear regression, that was y is equals to mx plus c, we fit an s-shaped logistic function which predicts two maximum values. Either it will be 0 or 1 on the maximum side. The curve from the logistic function indicates the likelihood of something, such as whether the cells are cancerous or not, mouse is obese or not, and based on its weight, etc. So logistic regression is a significant machine learning algorithm because it has ability to provide the probabilities and classify the new data using continuous and discrete data sets. Logistic regression can be used to classify the observation using different types of data and can easily determine the most effective variables used for classification. So let us understand logistic regression with the help of this image. So here we are setting the threshold value on 0.5. So anything or the probability that logistic regression gives, let's say it predicts y is equals to 0.8. As 0.8 is above the threshold value of 0.5, so we'll consider it 1. And for example, if logistic regression predicts that y is equals to 0.3, and based on our threshold value it is less than 0.5, so we'll predict it as 0. So this is how logistic regression works with the help of this S curve. So you can generate that S curve with the help of this logistic or sigmoid function. It is just another mathematical function and it has a curve like the S shape that we already saw. So the sigmoid function is a mathematical function used to map the predicted values to the probabilities. Now it maps any real value into another value within the range of 0 and 1. The value of logistic regression must be 0 and 1, which cannot go beyond this limit. So it forms a curve like S form. The S form curve is sigmoid function or the logistic regression function. In logistic regression, we use the concept of threshold value, which defines the probability of either 0 or 1, such as values above the threshold value tends to be 1 and values below the threshold tends to be 0. This we already discussed. Now, these are some of the mathematical equations that are important for logistic regression. So the logistic regression equation can be obtained from linear regression equation. The mathematical steps to get logistic regression equations are given below. So we know the equation of a straight line can be written as y is equals to b naught plus b1x plus b2x2 plus b2x3 and so on and so on. In logistic regression, y can be 0 and 1 only. So for this, let's divide the above equation by 1 upon 1 minus y. So y upon 1 minus y, 0 for y equals to 0 and infinity for y equals to 1. If you divide anything by 0, it becomes infinity. And if you so we need the range between minus infinity to plus infinity, and take any logarithm, then take the logarithm of the equation, and it will become log of 1 upon y upon 1 minus y is equals to b naught plus b1 x1 plus b2 x2. So this is how you derive the equation of logistic regression. Now enough of the mathematics. Now let's move to the Jupyter notebook and try to implement the logistic regression algorithm in Python. So let us start with the practical implementation of logistic regression. I have imported pandas and numpy. Now let me create a data frame. So let's name it df, and we have pd.read csv, and the data set that I'm going to use is user data.csv and df.head. Let us see what we have in the data. So these are the columns that we have. First is user ID. This we are not going to use. So gender, age, estimated salary, and purchased. Now gender tells about the is a feature of the customer, age and estimated salary, and purchased tells that whether the customer has purchased that item or not. So if we have the value of purchased as 0, then probably the customer has not purchased that item, and if we have purchased is equal to 1, then the customer, he or she, has purchased that item. Now we already have a good idea about all the features that we have in the dataset. Now let's separate the x and y, or the dependent or the independent features. So df dot iloc, and here what I'm going to do, so 2 comma 3, and then a closed bracket dot values. So this will be our x. We'll do the same for y. So df.iloc, let me copy this and I'll paste it over here, and I only want 4, or the purchased or not purchased. So this will be our y. So let me see what do we have in x, and y is the 0 and 1. Now let's train and test. Let's split the data set into train and test. So from sklearn.model underscore selection import train test split. Now I'll make x train, then I have x test, then I have y train, and I have y test, and this is equal to our x and y that we already made. So x, y, and test size, let's keep it 20% of the data for testing. Okay, so this we are having an error. Okay, I have to write train test and split. So now we have x train, x test, and y train, y test. Now let's perform scaling. So from sklearn dot pre-processing import standard scalar. Now let me create the instance for the scalar. So standard scalar for x, and this will be an object of standard scalar. Now firstly I'll fit transform on x train, and again I'll store it back into x train. So st underscore x dot fit underscore transform, and this is again x train. Then x test will be st underscore x dot transform and x test. So now we are done. Now let's import the logistic regression model that we are going to use. So from sklearn dot linear underscore model, we will import logistic regression, and I'll create one classifier object. So CLF will be equal to logistic regression of, and then I'll fit or train this model on X train on Y train. So let me give the training sets X train and Y underscore train. So now we have the trained model ready. Let me predict the results and store it into ypred. So CLF dot predict, and here I'll use X test. So let me see what do we have in ypred. So these are all the predictions that the model has made. Now let's test the accuracy of the dataset with the help of a confusion matrix. So from sklearn dot matrix import confusion underscore matrix, and I'll plot the confusion matrix. So confusion underscore matrix, and this is for y pred and y test. So let me see what do we have in CM. So what we are getting is the confusion matrix. As you can see, we have a lot of elements present in the diagonal part of the confusion matrix, hence the accuracy is on slightly on the medium to high side. So hence we can say that logistic regression is a decent classification model on this dataset. Now let's move to the next video if you are clear with the concept. So thank you for watching and welcome to the video on SVM. SVM stands for support vector machine. So SVM or support vector machine is one of the most popular supervised machine learning algorithms, which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of SVM algorithm is to create the best line, or we can call it a decision boundary, that can segregate n-dimensional spaces into different classes so that we can easily classify the new data point into correct category in the future. Now the best decision boundary is called a hyperplane. Hyperplane is one of the most important and frequently used terminology while we are going to study SVM. So it is the best decision boundary in SVM. So SVM chooses extreme points or the vectors that will help in creating the best or the optimum hyperplane. Now these extreme cases are called as support vectors. Hence the algorithm is termed as support vector machine. So consider the below diagram in which there are two different categories that are classified using a decision boundary or a hyperplane. So in this diagram, as you can see, the two most extreme points of both the green and blue category are known as the support vectors, and this is the maximum margin or the distance separating those 2 points, and this is the maximum margin hyperplane. This is on the right side we have the positive side of the hyperplane, and on the left side we have the negative side of hyperplane. And here, for the ease of understanding, I'm using a 2D a dimensional space or a coordinate axis, but in real life problems you can have a n dimensional vector space. So this is the basic working of SVM. Now have a look at this diagram. Here what we have some labeled or training data. So we have two different types of images in the data set. One is for cat and another is for dog. So as usual in the machine learning procedure that we follow, let's say we use the 80% data for training the model. This is the labeled data. So each image will have a label whether it's a cat or a dog. So all this 80% of the data will be given to the model for training. Now this new data point, and this will be a non-labeled data point. Once the model is trained, it will be given to this model, and finally based on the patterns that it has extracted from the training data, the model will predict that this new data point it's a cat. So this is how the SVM works, just like any other supervised machine learning algorithm. Now let's study about the different types of SVM. So SVM can be of two types. The first one is linear SVM. Linear SVM is used for linearly separable data, which means if a data set can be classified into two classes using a single straight line, then such data is termed as linearly separable data, and classifier is used as linear SVM classifier. So again, going back to the image, all the data points inside the data set can be just separated by a single linear straight line. So this is an example of linear SVM. Another slightly complex version that we have is a non-linear SVM. So non-linear SVM is used for non-linearly separated data, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used is called non-linear SVM. So we can tune the hyperparameters in SVM, and we can fit the SVM function on linear or non-linear data. That is about the coding part, and we'll discuss it once we are done with the theory presentation. So important terms in SVM, the hyperplane and support vectors. So hyperplane, there can be multiple lines or decision boundaries to segregate the classes in n-dimensional space. But we need to find out the best decision boundary that helps us to classify the data points. So this best decision boundary is known as the hyperplane of SVM. The dimensions of a hyperplane depends on the features present in the dataset, which means if there are two features present in the dataset, then the hyperplane will be a straight line, and if three features are present, then the hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between two data points, so it can separate the data points very clearly, and we want the best fit hyperplane. And again, the support vectors, so the data points or the vectors that are closest to the hyperplane. So once we have found out the hyperplane, the plane that is separating two different classes, and the data points that are closest to that particular hyperplane that we are using, that is known as the support vectors, which affect the position of hyperplane, are termed as support vector. Since these vectors support the hyperplane, hence these are called the support vectors. So let's understand with this practical example. So the working of SVM algorithm can be understood by using, suppose we have a dataset that has two tags, green and blue, and a dataset has two features, x1 and x2. We want a classifier that can classify pair x. Suppose we have a new data point x1 x2 with the coordinates x1 and x2, and we want it to be classified into a green or a blue category. So in this image, now what we can do, suppose it's a 2D space. So just by creating or using a single straight line, we can easily separate these two classes. But there can be multiple straight lines that can separate these classes. So we can have this brown kind of straight line, or we can also have this green straight line. Both these lines are clearly able to separate blue and green classes. But the SVM algorithm helps us to find the best fit line or the decision boundary that we can use. So this best boundary or region is called a hyperplane. So this is the optimal hyperplane based on the distances calculated from the support vectors. So this is where the role of SVM comes into picture. So SVM algorithm finds the closest point of the lines from both the classes. These points are called the support vectors that we already discussed. The distance between the vectors and the hyperplane is called the margin. This is a new term. So the distance between the optimal hyperplane that the SVM is determining and the support vectors is called a margin, and the goal of the SVM is to maximize the margin. So based on the maximizing the margin, this is the concept. So based on that, from whichever hyperplane we are getting the maximum margin, that will be considered as the optimal hyperplane by SVM. So the hyperplane with maximum margin is called the optimal hyperplane. So this is the core concept of SVM. I hope you are very clear with this. Now let's move to the Jupyter Notebook and try to implement SVM. Let us start with the practical implementation of SVM. First of all, I'll import pandas as pd and import numpy as np. Then I'll create one data frame to store the CSV file that we are going to be using for the SVM. So let's call this df is equals to pd.read underscore CSV, and here I'm going to use user data.csv. So let's see what do we have inside our data frame. So the entire CSV file is loaded. Now Next thing what we can do, we can separate the dependent and the independent features, basically the x and y that we use. So for x, I can use df of I want age and estimated salary. So these are the two features that I'm going to use for x, or maybe the independent features. And the dependent features that we are trying to use or basically predict is purchased. Now let's see what do we have inside x and y. Okay, so x dot, so age and estimated salary are the independent features, and we have y dot head, the purchased column, that is we are trying to predict. So let's train and split the data set into training and testing. So from sklearn dot model underscore selection import train test split. Now I will make x train, x test, y train and y test. So x train, then I have x test, then y train, and finally y test. This will be train test split, and the features are x and y, and I will use 80% data for training, so the rest 20% will be for testing. So this is done. Now let's import the SVM classifier. So from sklearn dot svm, as we are solving a classification problem, so I will import svc, that is support vector classifier. So it is done. Now let's make the classifier instance. So svc, and we are going to use the linear kernel that we already discussed in the theory part. So you can change the hyperparameters and tune them and check the results accordingly. For this I'm going to use the linear kernel, and let me run this cell. So kernel, okay, we have made a spelling error, so this is kernel. Now let's train it with the help of x train and x test. So we'll use the fit function, and I'll give x train and y train. So the model will take some time to train. Once it is done, you will get something like this. Now let's make some predictions. So I'll write ypred clf, and I'll call the predict method, and I'll give x test over here. So we have all the predictions inside the ypred. Let's see what is there. So ypred, all the 0 1 0 1 0 1 that the model has predicted. So now what we can do, we can check the accuracy of the SVM. So from sklearn dot matrix import accuracy underscore score. So these are the this is the accuracy score metric that the sklearn gives us to check the accuracy of a classifier. So I can write accuracy underscore score, and here I have my y test, and then I'll give my ypred. So it will compare the results that are stored in the y test, and it will also with the results that the model is predicting, and it will tell us the accuracy. So the accuracy that we are getting is about 86.25%. That is actually a pretty decent accuracy for without doing much hyperparameter optimization. So SVM is working quite good on the dataset that we are using. So I hope you are clear with working of SVM and also the practical implementation of SVM. Now let's move to the next. Hello and welcome to the video on decision tree algorithm in machine learning. So decision tree is a supervised learning technique that can be used for both classification and regression problems, but mostly we use decision tree to solve the classification problems. So it is a tree structure classifier where internal nodes represent the features of the dataset, branches represent the decision rules, and each leaf node represents the outcome. So in a decision tree there are two nodes, which are the decision node and the leaf node. Decision nodes are used to make any decision and have multiple branches, where leaf nodes are the output of those decisions and do not contain any further branch. So the decision or the tests are performed on the basis of features that are given in the dataset. So it is a graphical representation for getting all possible solutions to a problem based on the given conditions. We call it decision tree because the structure is similar to a tree, and it starts with a root node which expands on further branches and constructs like a tree. So in order to build a decision tree, we use the CART algorithm, which stands for classification and regression tree algorithm. As already discussed, we can perform both classification and regression tasks with this algorithm, hence the name CART. So decision tree simply asks a question based on the answer yes or no, and it will split the tree into next subtree structure. So by seeing this image you will get more clarity. This is the decision node or the root node. Now based on a certain if else condition, we will split this decision node into two subtrees. So this is one entire subtree and this is another entire subtree. Now these all leaf nodes are having the decisions made by all these subtree structures. So why do we use decision trees? There are various algorithms in machine learning. So to choose the best algorithm for the given dataset, the main point to remember is that decision tree they usually mimic human thinking ability while making a decision, so it is easy to understand. Now the logic behind decision tree can be easily understood because it's just a tree like structure, so we can easily derive back the logic based on which the decision was made or the prediction or the classification was made. Now few important terminologies before moving on to the decision tree working. So root node is from where the decision tree starts. So the first or the top node is known as the root node. It represents the entire dataset, which further gets divided into two or more homogeneous datasets. So once we make 2 or 3 splits on the root node, then the entire dataset is divided into 2 or 3 subtree structures. Now leaf node is the final output node, and tree cannot be segregated further after reaching to a leaf node. Splitting is the process of dividing the decision node or the root node into subnodes according to the given conditions. Here we want to see this term called branch or a subtree. So a tree that is performed as splitting the tree. So this is a subtree that we are getting. Pruning is the process of removing unwanted branches from the tree. This is very similar to the gardening term that we use, pruning. Parent and child node. The root node of the tree is called the parent node and other nodes are called the child nodes. Now have a look at this picture and we'll try to solve the example. So suppose there is a candidate who has a job offer and wants to decide whether he should accept the offer or not. This is our main problem statement. Now to solve this problem, the decision tree starts with the root node salary attribute. So salary will be considered as the root node as the parameter of making the decision. So the root node splits further into next decision node, that is distance from the office, whether office is located close to home or not, and one leaf node based on corresponding labels. The next decision node further gets split into one decision node cap facility, this is another factor, and one leaf node. Finally the decision node splits into two leaf nodes accept the offers and decline the offer. So here as we are taking salary is between 50,000 to 80,000, this is the root node. If yes, then we'll think further about the location of the office. If the salary is less than $50,000, then straight away we'll reject or decline the offer. So no further questioning, we cannot accept that offer. But if the salary ranges between 50,000 to 80,000, then this path will be taken and the next question will be asked whether the office is near to home or not. Again, if the office is not near to home, declined. So this is another decision, offer declined. But if the office is close to home, then we'll ask the next question. Does the office provides cab facility? If yes, then we'll finally accept the offer. So to accept the offer, we have to take this part and all the conditions should be satisfied. Otherwise, on the other side of the tree, that we can straight away decline the offer. Now, finally, let us understand some of the disadvantages of using a decision tree. So the decision tree contains a lot of layers, which makes it slightly complex. Sometimes checking too many conditions, it becomes a little complex. Now this may also lead to an overfitting issue, which can be resolved by using the random forest algorithm. This is another very important and very super powerful machine learning algorithm that we are going to cover in the next few videos. For more class labels, the computational complexity again of the decision tree may increase. So these were some of the disadvantages of decision tree. I hope you are clear with the basic concept and working of decision tree. Now let's move to the Jupyter notebook and try to implement the decision tree algorithm in sklearn. Hello and welcome to the practical implementation of decision tree. So let us start. Import pandas as pd, import numpy as np. Now I'll create one data frame and we'll use the user data.csv that we were seeing in the videos of logistic regression and other classification algorithms. So df is equal to pd dot read underscore csv and we have user underscore data dot csv. So let's check our df. So this is the dataset that we are working with. Now we'll extract the dependent and independent features. So what I'll do, x will be df of I'll use gender and let's say age, and the third one is sg mated salary, and y will be df of purchased. So this we have separated our dependent and independent features. Now let's import from sklearn dot model underscore selection, import train test split. Now I'll make x train, x test, y train and y test. So x train, x test, y train, and then I have y test. This will be train underscore test and then split. Here I will give x and y, and my test underscore size will be of let's say 20%. So this I have separated my x train and x test. Now we'll import the decision tree classifier. So from sklearn dot tree import decision tree classifier. Then I'll make one instance for the classifier, that is clf, and decision tree classifier. So the clf is trained. Let me mention the criteria that we want to use, that is the entropy. So criterion, that will be entropy. So again I have a train classifier. Oh, I have my instance ready. Now let's train this. So clf dot fit method, and I'll train it with x train, and I have y train. So this is training. Okay, could not convert string to float. Okay, we have this, we are using the gender attribute, that is a categorical variable, and so we are not going to perform the feature encoding. So as of now let's remove the gender attribute and work with the remaining two. So now this classifier is ready. Now what we'll do, let's make some predictions. So y underscore pred will be clf dot predict, and we want to predict on x test. So these are all our predictions. Now let's see what do we have inside y pred. So all 10 10 10 the predictions that we have. Now let's import from sklearn dot matrix import accuracy score. So we'll be working with, we'll try to find the accuracy of our model. So accuracy underscore score. Now what we'll do, accuracy score, this will be y test and y pred. So we are getting a very good accuracy of 87.5%, which is actually a really good accuracy for a machine learning model. So this was the practical implementation of decision tree. We used the user dataset to predict whether the customer will purchase the item or not based on the gender, age and estimated salary, and we are getting accuracy of 87.5%. So I hope you are clear with how decision tree works. Now let's move to the next video. Thank you. Hello and welcome to the video on random forest algorithm. Random forest is one of the most popular machine learning algorithm that belongs to the supervised learning technique. Again, random forest can be used for both classification and regression problems. It is based on the concept of ensemble learning, which is process of combining multiple classifiers to solve a complex problem and then improve the performance of the model. So most of the time, if you try a few different algorithms like logistic regression, SVM, KNN, decision tree and random forest on different classification problems, most of the time random forest will be best performing model without any hyperparameter optimization. So this is a go-to ML algorithm for most of the ML engineers out there. So as the name suggests, random forest is a classifier that contains a number of decision trees on various subsets of a given dataset and takes the average to improve the predictive accuracy of that dataset. Now, instead of relying on one decision tree, the random forest takes the prediction from each tree and based on the majority votes of predictions, it predicts the final output. So the greater number of trees in the forest leads to higher accuracy and it also prevents the problem of overfitting. If you remember carefully from the video of decision tree, in the disadvantage section of the decision tree, we mentioned that sometimes due to the increasing length of decision tree, it tends to overfit on the data. So this problem can be prevented by using random forest. Now this is a visual representation of how random forest works. So training data set 1, training data 2, training data n. Now again you have a first decision tree, second decision tree and the end decision tree. Now you take the voting or averaging of all the decisions given by these different decision trees on different subsets of training data. And finally after averaging you give the final prediction. Now this is how random forest works. Now let's take one example. So suppose there is a data set that contains multiple fruit images. So this dataset is given to random forest classifier. The dataset is divided into subsets and given to each decision tree. So here you have a dataset that contains multiple fruit images. Now this dataset is given to random forest and this dataset will be divided into subsets and each subset is given to a new decision tree. So during the training phase, each decision tree produces a prediction result. So this decision tree, let's say, predicts that this belongs to class A. The second decision tree tells that this belongs to class A, and the third or the nth decision tree tells that this belongs to class B. Now then, when a new data point occurs, then based on the majority vote results, the random forest classifier predicts the final decision. So as the majority vote is for class A, so the final predicted class will be class A based on the entire random forest algorithm. So this is how the random forest algorithm works. I hope you are very clear with the working of random forest algorithm. Now let's move to the Jupyter notebook and try to implement and see the accuracy that we are able to achieve by simply using random forest algorithm. So let us start with the practical implementation of random forest. First of all, let me import pandas and numpy. So import pandas as PD and import numpy as np. Okay, we have here pan, import pandas as PD. Now what we'll do, I'll import the dataset as a data frame. So df.pd.read_csv, and here I am using user data.csv, and let's see what do we have inside the dataset. So these are the attributes that we have inside the dataset. Now we'll split up the x and y or the dependent or independent features. So df of the independent features will be age and let's say estimated salary. So we are using these two columns to predict whether the customer will purchase or not. So df of purchased. Now after this, let me split the dataset into training and testing part. So from sklearn.model_selection, import train test split. It will take some time to import and it's done. So I'll make my X train, then I have X test, then Y train and Y test. This is train test split and I'll use X and Y. I want to use 20% data for testing, so test size will be equal to 0.2. So now I have my X train, X test, Y train and Y test. Now let us import our random forest classifier from the sklearn.ensemble. So from sklearn.ensemble import random forest classifier. So now I'll make one classifier instance. So CLF will be random forest classifier. As of now, I am not giving any specific hyperparameters. I want just a default classifier and I want to train this. So I'll use the fit method and I'll train it with the help of X train and Y train. So X train and I have Y train. So based on this, I'll train my random forest classifier. Now next thing I want to do, I want to check the predictions. So Y pred will be equal to CLF dot predict and I want to predict X test. So all the predictions will be stored in ypred. As you can see, we are getting all 0 1 1 0, all the predictions. Now let's check the accuracy that we were able to achieve with the help of the random forest model. So from sklearn dot matrix import accuracy score. Now I will write accuracy score is let's say Y test and Y pred. So again we are getting 87.5% accuracy by using the random forest classifier. So for a normal machine learning model without performing any hyperparameter optimization, we are able to achieve such a good score of 87.5%. So I hope you are clear with the practical implementation and basic understanding of random forest. Now let's move to the next video. Thank you. And welcome to the video on k-means clustering algorithm. This is the first unsupervised machine learning algorithm that we are going to cover in our course. So let us start. K-means clustering is an unsupervised learning algorithm which groups the unlabeled data into different clusters. Here, K defines the number of predefined clusters that need to be created in the process. As if K is equals to 2, there will be 2 clusters created, and if K equals to 3, there will be 3 clusters created, and so on. So it is an iterative algorithm that divides the unlabeled dataset into K different clusters in such a way that each dataset belongs only to one group that has the similar properties. Now it allows us to cluster the data into different groups and a convenient way to discover the categories of groups in the unlabeled dataset on its own without any need of training. As this is an unsupervised learning algorithm, so we don't have that training, testing and all that part that we used to do in algorithms like random forest, decision tree, logistic regression, etc, etc. So it is a centroid based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distances between the data point and their corresponding clusters. So this is the graphical representation of k-means algorithm. So before applying the k-means clustering, this is a simple scatter plot of the data that we had. Now once we performed k-means clustering on this data, now we have something like this. So this one is considered as one single blue cluster. This green one is the second cluster on the top, and third cluster is the black dots that we have on the right hand side. So let us understand how does the k-means algorithm work? So the working of the k-means algorithm is explained in the below steps. So the step 1 says that we have to select the number k to decide the number of clusters. Now we will see the elbow method that is used to determine the number of clusters that we are going to make from the dataset. So the first step is to decide the number of clusters that we want to create. For that, I'll teach you about an elbow method later in this video. Now second, select random k points or centroids. It can be other from the input dataset. Now step 3 says that assign each data point to their closest centroid, which will perform the predefined k clusters. Now step 4, calculate the variance and place a new centroid of each cluster. Repeat the 3 steps, which means assign each data point to a new closest centroid of each cluster. If any reassignment occurs, then go to step 4 or finish it. Now the model is ready. So let us understand this. Suppose we have two variables m1 and m2. The xy axis scatter plot of these two variables is given below. So this is a scatter plot. Now let's take number k of clusters. We want to make two clusters out of the scatter plot and the dataset and to put them into different clusters. It means here we will try to group these datasets into two different clusters. Now we need to choose some random k points or centroid to form the cluster. So these 2 points can either be the points from the dataset or any other point. It doesn't matter. So here we are selecting the below 2 points as the k points. So we are selecting these 2 points as the initial cluster centroids, which are not the part of dataset. So these 2 points are not the part of dataset. We are selecting them as the initial cluster centroid. Now we will assign each data point of the scatter plot to its closest k point or centroid. We will compute it by applying some mathematics that we have studied to calculate the distance between 2 points. So we'll draw a median between both the centroids. So from the above image, it is clear that the points on the left side of the line lie near to k1 or the blue cluster center, and points to the right side of the line are close to the yellow centroid. So let's color them as blue and yellow for clear visualization. So after, this is the initial two clusters that we have made after selecting a random centroid. Now as we need to find the closest cluster, we will repeat the process by choosing a new centroid. To choose new centroids, we'll simply compute the center of gravity for these centroids and we'll find new centroids as below. Now we will reassign each data point to the new centroid. For this we will repeat the same process of finding the median line. The median line will look like the given image. So this is after changing the center of gravity for the clusters. Now we can see one yellow point is on the left side of the line and two blue points are on the right side of the line. So now these three points will be reassigned to the new centroids. Finally it will look something like this. So all the blue points are on the upper side of the line, and the yellow points are below the line. So as reassignment has taken place, we will again go back to the step 4, which is finding new centroids or k points. So we'll repeat the process by finding the center of gravity of centroids. So the new centroids will be shown in the below image. Now we got new centroids. So again we'll draw the median line and reassign the data points. So the image will look something like this. Finally, we can see in the above image there are no dissimilar data points on either side of the line, which means our model is formed. In this image, now our model is ready and we can remove the assumed centroids and two final clusters will be shown as you can see in this image. So this is how k-means clustering works. I hope you are very clear with the basic working of k-means. Now let's move to the practical section and try to implement it in the Jupyter notebook. So let us start with the practical implementation of k-means algorithm. In this cell I have imported all the required libraries. So we'll be using NumPy, Matplotlib and Pandas. So importing the dataset inside a Pandas data frame. So mol customers.csv by using pd.ratecsv. Have a look at this dataset. We are having customer ID, gender of the customer, age of the customer, annual income in $1,000 and spending score in 1 to 100. So based on all the features, all the different features that we have for the customers in our data set, we have to cluster them. So a practical use case of this k-means or customer clustering approach can be the retail store or the online store can throw up different offers to the different customers falling in different clusters. Let's say a customer with the high annual income and high spending score will receive the offers for slightly expensive things, and in case if a customer is not that old or has a low income or does not have a very high spending score, so the store can pitch or sell or advertise cheap products to that customer. So based on the cluster of that customer, the store can advertise different products. So this can be used for effective marketing. So this is the data set that we're going to use. Now these are all the features that we are going to take into account, and here in unsupervised learning techniques we don't have to use the x and y or the dependent or independent features. We just simply have to choose the features from the data set. So if I add one more cell and if I write x over here, so these are the two features that we are going to use. So annual income and spending scope. Now moving on, as I told you, we are going to use something called an elbow method to find the optimum number of clusters. So the code for elbow method is given over here, and the full form for WCSS is within cluster sum of squares. We are not going to go in a lot of mathematical detail about this elbow method, but simply by using the elbow method you can plot this elbow shaped graph, and the optimum number of clusters will be the point on the graph where the graph starts to flatten. So here in our case, this can be the optimal cluster point or the elbow point of the graph. So this is for 2, 3, 4 and 5. So this is almost 5. So we can get a decent idea about the number of clusters. So based on this elbow graph, we can directly say that the number of clusters that we are going to make from the given dataset will be 5. You can try the code for elbow method on different datasets and try to figure out the optimum number of clusters as a practice. So here I am calling the k-means model, and the number of clusters that I am going to use is 5. And then k-means dot fit predict. This is the method fit predict that we are going to use when you're working with unsupervised learning algorithm. Now here, as we are not predicting a certain value, so there's no point of accuracy or any other metric. So we'll simply visualize all the clusters that we have made. The code for visualizing the clusters is given over here. Clusters of the customer, annual income is on the x-axis and spending score is on the y-axis, and based on all the both the features, we have created 5 different clusters: light blue, dark blue, pink, red and green. So these are the 5 different clusters that we have created, and the yellow ones, the yellow dots are for the cluster centroids. So this was the working of k-means clustering algorithm. I hope you are very clear with this. Hello and welcome to the video on hyperparameter optimization using grid search CV. So first of all, let us understand what are parameters and hyperparameters in machine learning. Before we dive into tuning your hyperparameters, let us take a moment to recap what the differences are between the parameters and the hyperparameter in the machine learning model. So parameters in a machine learning model refer to the variables that an algorithm itself produces, such as coefficient, let's say, to produce a prediction. Now these parameters are not set or hard coded and depend on the training data that is passed into your model. Because of this, they are likely to change as the data changes. On the other hand, hyperparameters are variables that you specify while building a model. This means that it's a user that defines the hyperparameter while building the model. For example, in KNN algorithm, the hyperparameter can be as the value of k, that is the nearest neighbors. Such as in algorithms like in decision tree or random forest, the hyperparameter can be the depth of the tree or the number of trees, like that. Now in short, hyperparameters control the learning process while parameters are learned. This is the key statement. Hyperparameters control the learning process and parameters are learned. So this is where the art of machine learning comes into play. The choice of your hyperparameters will have a significant impact on the success of your model. So being able to tune your model is and finding the best hyperparameter is very important. So hyperparameter tuning in machine learning. Hyperparameter tuning refers to the process of finding the hyperparameters that yield the best result. This of course sounds a lot easier than it actually is. Finding the best hyperparameter can be an elusive art, especially given that it depends on largely the training and the testing data that you are using. So as your data evolves, the hyperparameters that were once high performing may not perform well. Keeping the track of the success of your model is critical to ensure that it grows with the data. So one way to tune your hyperparameters is to use a grid search. This is probably the simplest method as well as the most crude. In a grid search, you try a grid of hyperparameters and evaluate the performance of your model on each combination of the hyperparameters. So we'll try each combination that we give in the grid. So this is about grid search CV. Now let's explore the grid search CV class. So in the grid search CV, the first argument that we can give is the estimator or the sklearn model that we are using. It can be any model, random forest, decision tree, KNN, logistic regression, any model that you want to use. Paramgrid, this will be a dictionary of parameters with names and values. So a parameter for KNN model can be the number of nearest neighbors, but the parameter for a random forest may be the number of decision trees or the length of the decision tree. CV, an integer that represents the number of k-folds. Scoring, the performance measure such as R2 or precision. So let's say you are working with a random forest regressor, then the performance metric can be the R2 score as it's a regression problem. But if you're working with a classification problem with the same random forest algorithm, then the performance metric can be the precision, accuracy, or recall, anything that you want. N jobs, the number of jobs to run in parallel. Verbosity 0 to 3, the higher being more. This basically gives you the information about the steps of the running. Now, again, estimator takes an estimator object, such as classifier or a regression model. Param grid, it takes a dictionary or a list of dictionaries. The dictionary should be in key value pairs, where the key is the hyperparameter and value are the cases of the hyperparameters, that the values that we want to test. CV takes an integer that determines the cross validation strategy to apply. If none is passed, then automatically 5 will be used. Scoring, this is a string or a callable. This represents the strategy to evaluate the performance of the test set. Now n jobs represents the number of jobs to run in parallel. Since this is a time consuming process, running more jobs in parallel, if your computer can handle it, can speed up the process. Verbose determines how much information is to be displayed. Using a value of 1, it displays the time for each run. 2 indicates that the score is also displayed. 3 indicates that the fold and the candidate parameter is also displayed. So I hope you are clear with the basic concept of grid search CV and hyperparameter optimization. Now let's move to the Jupyter notebook and perform the practical for grid search CV. So let us start with the practical example of grid search CV. First of all, I will import all the necessary libraries. So import sklearn dot datasets. Okay, here I need to write from sklearn dot datasets import load breast cancer from sklearn dot matrix import classification underscore report, and we'll also use the confusion matrix confusion underscore matrix from sklearn dot svm import svc from sklearn dot model selection import grid search CV, and again from sklearn dot model selection import train, test, split. So what in this example I'll show you how to find the best parameters for a support vector classifier or a SVM model, and we are going to use the breast cancer dataset and try to solve the classification problem. So let's load the dataset. So dataset will be equal to load breast cancer. So X will be our dataset dot data and Y will be our dataset dot target. Now let's perform the train test split. So I have X train, X test, Y train, Y test, that will be equal to train test split, and then I have X, Y test size, let's keep it 20%, and then let's fit the model first without using grid search CV. So let's see how it is performing. So SVC and then model dot fit on X train and Y train. Now let's make some predictions. So predictions will be equal to model dot predict, and we want to predict for X test, and let's get a classification report for our Y test and predictions. So this is the initial classification report for without using the grid search CV. Now let's define a parameter range that we are going to use for grid search CV. So various parameters for SVM can be the C value, gamma, and let's say the kernel. So I'll make one param grid. So let's write param grid and a dictionary. The first thing that I want to get is C, and this will be a list of values. Let's say 0.1, and then I have 1, then 10, and then 100. Then I want to get the optimum gamma value. So again a dictionary 1, 0.1, then 0.01, then 0.001, and then 0.0001. Again gamma. So the scale or auto, and the last thing is the kernel. So as of now let's go with the linear kernel, otherwise it will take a lot of time to run. And then now let's make this grid. So grid search CV, the model that we are using is SVC, then we have our param grid, and then refit will be equal to true, verbose will be equal to 3, and an underscore jobs will be equal to -1. Now let's fit this grid. So grid dot fit X train, Y train. So this will take some time to completely run, and then after this runs successfully, we'll get the best parameter after the tuning. So let's wait till the grid is fitting. As I told you that if we don't specify the number of CVs, then it will automatically go with the 5 folds. So here, to get the list of best parameters, what I can write, grid dot best underscore params underscore. This will give me the list of best parameters once the grid is done fitting. Then I can write grid underscore predictions and will make predictions from this grid. So predict, again I have X test, and finally I can get the classification report. So the best parameters that I'm getting is the value of C should be 10, gamma scale and kernel is linear. So these are the best parameters, and based on this, if we run the model, then I'll get a better result. Now finally I can print the classification report. So classification report, and this will be again for Y test, and here I'm going to use the grid predictions. First of all, I have to run this cell, and then I can run this thing by using the optimum parameters. This is the perfectly tuned model. So this was about the practical implementation of grid search CV. I hope you are clear with this concept. Now let's. While data preparation and training a machine learning model is a key step in machine learning pipeline, it's equally important to measure the performance of this trained model. How well the model generalizes on the unseen data is what defines adaptive versus non-adaptive machine learning models. By using different metrics for performance evaluation, we should be in a position to improve the overall predictive power of our model before we roll it out for production on unseen data. So once we have trained the machine learning model, then we'll test it on the unseen data. And most important part is for judging the performance of the model is how well it performs on unseen data. So to measure it in quantitatively, we have different metrics. That's the only thing. Without doing a proper evaluation of the ML model using different metrics and depending only on accuracy, it can lead to a problem while the respective model is deployed on the unseen data and can result in poor predictions. So once you have already deployed the model and then you realize that the model is not performing well on the unseen data, then it will create a problem. So this happens because in the cases like our models don't learn but instead memorize, hence they cannot generalize well on unseen data. So the first important metric for a classification problem is confusion matrix. A confusion matrix is a matrix representation of the prediction results of any binary testing that is often used to describe the performance of the classification model or the classifier on a set of test data for which the true values are known. The confusion matrix itself is simple to understand, but related terminology for confusion matrix can be confusing. So this is how we use confusion matrix. So on the x-axis or the top, we have predicted values, the values that predicted by the model, and here we have the actual values. So the first is 0 0 1 1. So here true negative, the values that the model identified negative and were actually negative. So this is why this is known as true negative. Over here this is false positive. The model actually predicted positive or 1 for that outcome, but it was actually negative. So this is the false prediction made by the model. So this is false positive. In this cell we have positive and negative. So our model predicted it to be negative, but actually it was positive. So this is against a false prediction, that is false negative. And over here we have a true positive. So the model predicted it to be positive and actually also it was positive. So this is a correct prediction. So true positive. So true negative, false positive, false negative, true positive. Over here we have values that are predicted by the model, and here we have the actual values. So this is the terminology. Each prediction can be one of the 4 outcomes based on how it matches up to the actual value. So true positive, that is predicted to be true by the model and also true in the reality. true negative, predicted false by the model, also actually false in reality. False positive, predicted true by the model, but actually it was false in reality. And false negative, predicted false by the model, but true in reality. Now we calculate different metrics from the confusion metrics. So first one is accuracy. Overall, how often the classifier is correct. So accuracy is true positive plus true negative divided by the all four. So values that were predicted correct by the model and values that were predicted correctly negative by the model. Both of them will be considered over here and divided by the total cases that we have. So this is accuracy. Correctly identified divided by total. When our classes are roughly equal in size, we can use accuracy, which will give us correctly classified values. Accuracy is a common evaluation metric for classification problems. It's the number of correct predictions made as a ratio of all predictions made. Precision. Now, when it predicts CS, how often it is correct? So, when the model predicts CS, how often it is correct? When we have the formula goes like true positive divided by total number of yes predictions made by the model. Again, very simple. Truly positive divided by the total number of yes predictions made by the model. When we have a class imbalance, accuracy can become an unreliable metric for measuring our performance. For instance, if we had a 99 to 1 split between two classes A and B, where just any rare event B is our positive class, we can build a model that was 99% accurate just by saying that everything belongs to class A. Clearly, we shouldn't be building a model if it doesn't do anything to identify class B. Thus, we need different metrics that will discourage this behavior. For this, we use precision and recall instead of just simple accuracy. Recall or sensitivity. Recall is when it's actually yes, how often does it predict yes? So true positive rate, we also recall is also known as true positive rate. That is true positive divided by actual yes. Recall gives us the true positive rate, which is the ratio of true positives to everything else positive. Now, in case of the 99 to 1 split between classes A and B, the model that classifies everything as A would be having a recall of 0% for the positive class. B, precision would be undefined 0 by 0. Precision and recall provide a better way of evaluating the model performance in case of a class imbalance. So when you have imbalance, or let's say in your output data set, you have a 90 to 10 kind of split or 95 to 5 kind of split. So if you randomly predict class B, which is the 95% of the outcome, then the accuracy of the model will always be 95%. But here, due to data imbalance, precision and recall play an important role. Now MAE, which is an important metric for evaluating your regression model. So as seen by the formula, it is very simple. You subtract the value predicted by your model and you from the actual value. Let's say your model predicted the sales forecast of 100, but actually it was 95. So you subtract both of them and you add all the rows, and then you divide by the total number of observations. Here we use the absolute or mod value just in case to avoid negatives. So for example, if the model predicted 95 but the actual sale was 100, so we'll getting a negative value. That's why by taking the modulus of that value, it will convert it to a positive value. Basically the error will be clearly visible. Again, we have one more metric called MSE, mean squared error. Instead of taking absolute value, we take the square of the difference to avoid the negative value. And again, we add all of them and divide by the total number of observations. So these were the two important metrics for regression. I hope you are clear with different model evaluation metrics that we use in machine learning. We'll be using them in lot of in next few videos. So it is important to know this concept. Thank you for watching. Now let's move to the next video. Hello and welcome to the first video in the section of Matplotlib. In this video, we'll learn about the basic terminologies and keywords that are used in Matplotlib and what Matplotlib is all about. So let us get started. First of all, Matplotlib is a Python plotting library that is used for making various visualizations while we are performing data analysis. So to work with Matplotlib, first of all we need to install that, and to do that you can run this command called pip install matplotlib. This command will install Matplotlib on your system. I already have matplotlib installed on my system, so this will probably show requirement already satisfied. Now, to work with matplotlib in your Jupyter notebook, we need to import it as other libraries. So what we'll do, we'll write, as you can see here, it says requirement already satisfied. Now here we can write import matplotlib dot pyplot as plt. Now, most of the matplotlib utilities lie under a submodule called pyplot, and we are importing that as the alias plt. So this is, we import the matplotlib. Now starting before, we'll also cover different type of plots or graphs that you can make with matplotlib, like line chart, bar chart, scatter plot, pie chart, etc, etc. But for this video I'll just show you a simple line plot, and to plot a line we need some numerical values, so we will also import numpy as np. Now what we can do, a line has two axes, a plot has two axes, that is the horizontal and vertical axis. So the horizontal axis is called x-axis and the vertical axis is called the y-axis. So what we'll do, to plot the points on x-axis, I'll write x is equal to np dot array. I'll make a numpy array and I will, let's say, give 0 6, and y will be again a numpy dot array, and here I'll give um, let's say 0 80. So these are my 2 points on x and y axis. Now to make a simple line plot we have a function called plot. So we can write plt and we can call this plot, and here we will pass our x-axis and y-axis. And then to finally show the plot we have this function called plt.show. So as soon as I'll run this cell, I'll get this output. So this is x-axis, these are the 2 points, 0 0 is here and 6 80 is here. On the y-axis you can see we have coordinates starting from 0 to 80, and on the x-axis you can see we have coordinates starting from 0 to 6. Now we can perform various designing and other editing on this plot, like we can change the color of the line or we can change the pattern of the line and all that, but all that we'll see in the next video. As of now, this is just the introduction video. The important thing to remember is we'll be using matplotlib for most of our data visualization part when we'll move to the practical or more sort of a complete case study or project analysis. This is the basic introduction for matplotlib. The important thing for you to remember is that plt.plot function and plt.show functions, these are the functions that we use to plot our graphs in matplotlib. I hope you are clear with this concept. In the next video, I will show you different type of plots that we can make in matplotlib and somewhat editing about those plots. Thank you. Hello everyone and welcome to the next video in the section of matplotlib. In this video, we will learn about different type of plots that are available in matplotlib. We'll try to cover the most important ones that will be very helpful in your data analysis and visualization journey. So first of all, let us start the tutorial with the line chart. So we'll just import matplotlib.pyplot as plt as already discussed, and I'll also import numpy to generate an array based on integers that will be useful while making our line chart. So import numpy as np. I'll run this cell and we'll wait for it to execute. It will take some time to import the required modules and then we'll start. So it is done. Now we'll start. So what we'll do, we'll first generate some points that will be used to plot the line. So I'll make one numpy array called points, and to make an array in numpy we just use the array function, and inside this I'll pass a list. So let's say 4, 7, 2, 10 and 13. So these are the points that will be used to plot our line. Now next what we'll do, to plot a line plot in matplotlib, the function is plt dot plot. So this is the function that is used to plot a line. Now we'll pass, as we want to plot the line for this array, the data that is present in this array. So I'll pass this array over here, and then it will take some time to plot it, and finally the plot is ready and it's processing. So as you can see, it's now visible. So first point is 4, that is here. The next point is 7. The third point is 2. The fourth point is 10 over here, you can see on the y-axis, and the fifth point is 13. We can also write plt dot show to see the plot very clearly. So plt dot plot function is used to plot the graph, and plt dot show function is used to see that graph. Acha, we can make one more change over here. So what we can do, we can also write something like this. So plt, okay, let me make 8 to a new array np dot array, and this time I will pass 1 2 3 4 5 6, and then plt dot plot a2. I want to plot this over here, and this time I want to change the line style, and I want a dotted line. So you can use this line style feature to change the type of line, and then finally I'll write plt dot show. If I run this cell, this time as you can see I'm getting a dotted line. We can also try one more variation. Instead of dotted, we can type dashed, so I'll get this type of line. So I hope you are clear with the line plot. We'll also see many different types of line plots when we work on real-time data sets and the data analysis part, but as of now, just for introduction purpose, these are the only type of line plots that we're going to see. Now let's move to the next type of plot that we're going to see, that is the bar chart. So again, to plot a bar chart, what we'll do, we'll take two different types of data, that one will be a categorical and one be a numerical. So I'll make two different numpy arrays, one for the x-axis and one for the y-axis. So for x-axis, what I can do, np dot array, and here what I can write, x comma y comma z comma w, and for y-axis, that is our vertical axis, what I can do, np dot array, and here I can give some random numbers, let's say 25, 30, 27 and 22. So these are the two different data x and y coordinates that we are going to. Okay, so what okay, I have forgot to add the square brackets over here, and I'll put it over here, and again also for the y-axis I just have to add the square brackets. So that's why we were having one error. Now to plot a bar chart, we'll write plt dot bar. For line chart we were using plt dot plot, and we'll pass both x and y axis, and finally we can write plt dot show. So this is how you will get a bar chart. On the x-axis, as you can see, we have four different values, x, y, z, w, and on the y-axis we have 25, 30, 27 and 22. So this is the bar chart. The next chart that we are going to see is a scatter plot. So in bar chart we are working with one categorical and one numerical feature. In scatter plot we'll work with both the numerical features. So what I can do, again I'll make two different arrays. So let's say x1 np dot array, and this time I'll give some random values 20, 15, 11, 7, 8, 10. So I'm giving 6 different values, and y2 will be okay, y1 will be np dot array, and I'll again give some values, let's say 2 comma 7 comma 15 comma 8 comma 10 comma 12. So again 6 values for both x and y. And what I'll do, to plot a scatter plot, we have to write plt dot scatter, and here I'll pass both x1 and y1, and then I'll write plt dot show. So what this will do, this will plot a scatter plot. So on x-axis we have our 6 values that we give, 20, 8 and all the values, and on the y-axis we have all the values. So this dots or the points that we have on the graph represent 20, 2. So the first value will represent 20, 2, 20 on the x-axis and 2 on the y-axis. For example, this value will be 15 comma 15. So this is how the scatter plot works. We work with both numerical features. Now the next chart that we have is a pie chart. So what we'll do, again I'll make one array, let's say p, and np dot array, and let's give 30 comma 20 comma 25 comma 20, and what I'll do, plt dot pie, and I'll plot p. So this is how you get a pie chart in matplotlib. And the last final chart that we are going to see is a histogram. So to work with histograms, what I can do, again I'll generate some random values in numpy. So h1 will be np dot random dot normal, and let's say I just give over here 170 comma 10 comma 250, and then plt dot hist. This is the function that we use to plot a histogram, and I'll pass h1 over here, and as you can see we have a histogram ready in matplotlib. So these were some of the different plots in matplotlib. We'll study all the different plots in detail when we move to the main data analysis and visualization, but this was just an introduction to the different plots. I hope you are clear with this. Now let's move to the next video. Thank you. Hello everyone, and welcome to the video tutorial on Seaborn in Python. So Seaborn is another powerful Python plotting library that uses matplotlib underneath to plot powerful and impactful visualizations. Now first of all, let us understand how do we install Seaborn on our system. So again, by using the same pip command, we can write pip install Seaborn, and if I run this cell, I'm already having Seaborn installed on my system, so it shows me requirement already satisfied. Now the next step that we want to do is we want to import Seaborn. So I'll write import Seaborn as SNS, and I can also import matplotlib, import matplotlib dot pyplot as plt. So these are the two important libraries that we'll see. Now we are going to basically see three important plots in Seaborn. So first plot that we are going to see is the box plot, and the second plot that we are going to see is the dist plot, or the distribution plot that they call, so the dist plot, and the third plot is rect plot. So these are the three important plots that we are going to see in Seaborn. So first of all, let us start our journey of the box plot. So what I'm going to do, Seaborn already has some inbuilt datasets. You don't need to use any external CSV that we saw in pandas data frame. So I'll load one dataset that is already present inside Seaborn library into my pandas data frame. So I can also write import pandas as pd, and then I'll make a data frame df is equals to and sns dot load underscore dataset function. By using the load underscore dataset function, you can try to use the inbuilt datasets that are already present in CBON. So now I can write tips. There is a dataset of tips that is already given in present now in CBON. So I can see the data frame. So the dataset contains 244 rows and it has 7 columns. It gives us information about features like total bill, tip, the sex of the customer, smoker, day, time and size. So this is the basic information. Now to plot a box plot, what we can do, we can just simply do df dot box plot, and here I can write by, so it will be day, and then I can write column, that will be total underscore bill. So this will be total underscore bill, and the third argument will be grid, that will be false. Okay, so I have to write capital F over here. So as you can see, I have my box plot ready. Now first of all, let us understand what a box plot is and how we can interpret the data that we have visualized through box plot. So box plot is basically a visual representation of depicting groups of numerical data through their quartiles. These basic statistical measures that I already showed you, like you have the 25th percentile, 50th percentile, and the average, mean, median, etc., etc. So these are the basic statistical measures. Now box plot is also very important for detecting outliers in the dataset. Now the concept of outliers in the dataset is very useful when you try to implement machine learning models on the dataset. So if you are already aware about the kind of outliers that are present in different features of your dataset, so it will be very helpful to increase the accuracy of the prediction of your machine learning model. So that is why box plot is very important. Now it captures a summary of the data very efficiently in a simple box and whiskers and allows you to compare into a different groups. Box plot summarizes the sample data using the 25th, 50th and 75th percentile, and these percentiles are also known as the lower quartile, median and upper quartile. So this will be the lower quartile, median and the upper quartile. So a box plot consists of 5 things: the minimum value, the maximum, and the first quartile of 25th percentile, median, or the second quartile, or we can also call it the 50th percentile, that is the median, and the third thing is the 75th percentile and the minimum and maximum value. So this is why box plot is very important. You can detect outliers very easily with the help of a box plot. So if you are clear with the box plot, now let's move to the next type of plot that we are going to use, is the dist plot. So to do that, I'll use a new dataset, and let's use the Titanic dataset. This is a very famous dataset in data science. Most beginners have already worked on the Titanic dataset, and I'll also try to show you some important exploratory data analysis on the Titanic dataset in the next few videos. So what I can do, I can again write SNS dot load underscore dataset, and CBON already has Titanic dataset stored inside it, so we just have to import it inside a data frame. Now it is loading. It will take some time to load the Titanic dataset into from CBON to our pandas data frame. So yeah, it is done. So let's take a look what we have inside the Titanic dataset. So this Titanic dataset has these number of features. So what we'll do, I'll show you the box plot or the dist plot on the age feature, and I'll explain what the dist plot basically shows you. So what I can do, I can make one feature called age 1, and I will pick up the age column from the Titanic dataset, and I'll use drop NA function on this age 1. Now what does drop NA will do? It will remove all the null values that are present inside the age column, and it will give me a new feature age 1, which is essentially derived from the original age feature that we already had in the dataset. So this is done. Now what I can write, SNS dot dist plot, and inside the dist plot I want to give my new feature that I've made age 1, and I want, let's say, 30 bins, and the next thing I want to do is KDE will be equal to false, and I can write PLT dot show to cman disk plot. Okay, it is Titanic. Now I have the disk plot ready. So now what disk plot tells you, it gives you a basically a histogram. You can also try different features of disk plot. You can plot lines on the top of this histogram, but it is giving me basically the distribution of the age feature that I have inside my dataset. So if you try to interpret from the histogram, the maximum number of people that I have in the dataset are from, let's say, 15 to 55, and the majority of the chunk goes around 25. So on the x-axis I'm having the age of the people, and on the y-axis I'm having the count of the people. So this is how you can to know the density of the data points that are present in your dataset. So again, his disk plot is also very important while you build some important machine learning models. So if you are able to interpret all these plots very carefully, then you can tweak your machine learning models in a certain way to get the better accuracy and better results from your ML model. Now third and the most important plot that we have is the reg plot. Now again, I'll take a new dataset to show the reg plot. So what I'll do, I'll make a new variable called data, and again sns dot load underscore dataset, and this time I'll use, let's say, the mpg dataset. It will again take some time to load that data. It will load the mpg data that is already present in the cbin library into my new variable called data. So it's taking little too long to load the data. Let's wait for a few minutes and let's see what do we get. Okay, so the data is loaded. Now let's have a look what do we have inside the data. So the data contains these number of columns: mpg, cylinders, displacement, horsepower, acceleration, model year, and origin, etc, etc. Now my aim is to show you a rich plot, and I'll pick up two numeric features, acceleration and, let's say, mpg. So what I'll do, I'll write sns dot reg plot. Inside this, on the x-axis I want mpg, and on the y-axis I want acceleration, and then the data set I want to use is data will be equal to data, and I can write plt dot show to show the plot. Now as you can see, I have a rich plot. So on the background I have a basically a scatter plot that shows the distribution of different data points and between acceleration and mpg. Now reg plot, what it will do, it will be very useful when we are working with linear regression models. So if you understand the relationship between different features that are present in your entire data set, so it will be very easy for you to implement the best regression models, because the correlation between these two features, if the correlation is if you understand the correlation between different features, then the linear regression models will perform very nicely. Now what reg plot gives you is basically it gives you a best fit line and the scatter plot. So you can understand the distribution of the data between these two features, and you also have the best fit line that passes through or covers all the data points and gives you a basically average or the mean value of these two features. So this is how you work with reg plot, box plot, and disk plot in Seaborn. All these three plots are very important from the machine learning model point of view, so understand them very carefully. Now let's move to the next video. I hope you are clear with this concept. Thank you. Hello and welcome to the next video in the course of ChatGPT for data science and machine learning. In this video you will get the basic introduction about ChatGPT and how we can use it for rapid development of our data science and machine learning projects. So let us start. ChatGPT. Few basic questions that will be answered in this video. What is ChatGPT? Who built ChatGPT? How does ChatGPT works? Some advantages and disadvantages, like will ChatGPT end Google and human jobs? and how to create a ChatGPT account. ChatGPT, that is Chat Generative Pre-trained Transformer. That is the full form. Chat Generative Pre-trained Transformer. We are not going to get into a lot of technical details of transformers and deep learning models, but you just understand it's a very complex and advanced deep learning model that basically answers all your queries. So it is a chatbot developed by OpenAI and launched in November 2022. It built on top of OpenAI's GPT-3 family of large language models and has been fine-tuned. ChatGPT was launched as a prototype on November 30, 2022 and quickly garnered attention for its detailed responses and articulate answers across many domains of knowledge. ChatGPT is basically a chatbot which can answer almost every question every human can think about. So, how does ChatGPT work? ChatGPT takes your questions or requests and quickly answers them. This tool answered your questions using the database that it has. The model is trained using text databases from the internet. It contains 570 GB of data sourced from books, web texts, Wikipedia articles, and other pieces of writing on the internet. To be even more precise, 300 billion words have been fed into the system. You also get the option to tell whether you are satisfied with the answer given by it or not. Whatever answer you give, it also keeps updating its data continuously. So, some uses of ChatGPT: prompt and personalized responses. You can just randomly search any and every question that you want. Budget friendly. There are some paid plans of ChatGPT, but the basic that we are going to use will not cost you any money. Giving correct answers to your questions. The main advantage of ChatGPT is that when people search their query, it provides detailed answers to their questions, allowing you to learn everything about your query. When you search something on Google, many websites appear in a row, but here you can directly ask your questions and get answers. There's one interesting data point that I want to share you. The time that of these platforms took to reach 1 million users. So internet took 4 years to reach 1 million users. Facebook took 3.5 years. Instagram took 2 years. Google took 1.5 years. And ChatGPT just took 5 years to reach 1 million users. So this is an interesting data point that you should know. Now let us see, will ChatGPT replace Google? So it is unlikely that ChatGPT or any other single technology or a tool will replace Google as a company or an entire search engine. Google is multifaceted and widely used company that offers range of products and services, including searching, cloud computing, advertising, and even more. But ChatGPT is a language model that can generate human-like text and is trained to respond and prompts questions. And it is not designed to perform all the functions like advertising, search engine, everything that Google does. You will get more detailed and articulated answers on ChatGPT instead of Google. Like if you just search anything randomly on Google, you get different links to different websites and you can go through the website and find your answer. But ChatGPT, just like any other human like chatbot, it will give you a straightforward answer in the textual form. We'll see how we can use that practically in the next video. Thank you for watching. Now let's move to the next one. Hello and welcome to the next video in the course of ChatGPT for data science and machine learning. In this video, you will just get a quick introduction on how to use ChatGPT practically. Based on this video, and you'll get develop a basic understanding like how you can quickly search your queries on ChatGPT and how you can efficiently use this for the coding projects that we are going to start in the next few videos. So to get started with the ChatGPT, you just have to open this site called chat.openai.com/chat. Otherwise, in new tab you can simply search for ChatGPT, and the first link you will be finding will be this one, introducing ChatGPT OpenAI. So just have to click over here, and then this is the main site for OpenAI ChatGPT, and you just have to click on this button called Try ChatGPT. So you just have to open it in a new tab. If you are not already signed up with the Google account, so then you will get the first option to create an account, and then you will be redirected to this link. I already created my account, so I am directly getting this link. So you can just simply ask any question to ChatGPT. Let's say I'm working on a data science project and I want to quickly get a code snippet that will help me find out the null values in the pandas data frame. they can just simply search for null values in pandas data frame. So ChatGPT will give a basic description of the problem that we are trying to look, and it will give the is null method. Also, the best part is that you will get the code, so you can directly copy the code and run it. So otherwise, let's try one more example. How to read CSV files in Panda. So this is a very common step in every data science project. We'll be having a CSV dataset and we'll be working on that. So how do you read CSV data files in Pandas? So again, you will get a basic description and few lines of syntax for that particular problem that you are trying to solve. Here, you are also getting different options like delimiter and other things that you can use. So this is how we are going to use quickly ChatGPT and get the codes, develop the logic and build the projects that you will see in the next few practical coding project videos that you will find in the course. So I hope you're clear with the basic working and functions of ChatGPT. Now let's move to the next one. Thank you for watching. Hello and welcome to the introduction video of the car price prediction machine learning project of the course. In this video, you will get the basic overview of the project and the workflow that we're going to follow to implement this project using machine learning, and how can we build this project efficiently with the help of ChatGPT. So let us start. The features that we're going to use to predict the price of the cars will be the brand of the car, the year in which car was manufactured, selling price. This will be a target variable. That is what we're trying to predict. So this will be a typical regression machine learning problem. Then we have the present price of the car, kilometers driven, fuel type, the seller type, transmission type, and some previous owners of the cars. So we'll have information about all these different features about the car, and then we'll try to predict the selling price of that car. And the typical machine learning project workflow that we're going to follow will be something like this. So the first step will be we'll acquire the data. For the purpose of this project, you will have a CSV file that you can download from your resources section and follow along. Then we'll clean, prepare and manipulate the data so that our machine learning model can trace patterns from that and can make successful predictions. Then based on the cleaned and data pre-processing steps that we have done, we'll train the machine learning model, and finally we'll have some testing data that will be used to evaluate the performance of the machine learning model. If you're not satisfied with the performance of that machine learning model, so we can again tweak the parameters of the model, and then we can improve the performance of the model. So this is a typical project workflow that we are going to follow. So I hope you're clear with the project details and what we are going to build. So let's move to the coding part. Thank you. Hello and welcome to the next video in the course of ChatGPT for data science and machine learning. In this video, we'll start the coding implementation of our car price prediction project, and I'll show you how you can use ChatGPT to write the code and implement this project in a fast and easy manner. First of all, I'll import all the required libraries that we want. I will need pandas, so import pandas as PD. Then I have two plots of visualizations. I need matplotlib and cbon, so I'll import those two libraries. Import matplotlib dot pyplot as plt. Then I want import cbon as SNS. Then I'll implement the train test split. So we'll use 80% of the data for training the model and 20% for testing. So I want to split the data into two parts. So for that, I have to import from sklearn.model selection, import train test split. So from sklearn dot model selection, import train test split, and then I want to implement the linear regression model on this. Since this is the first project, I'm implementing just the basic linear regression model on this. So from sklearn dot linear underscore model I want to import linear regression, and to evaluate the performance of this model I will also import metrics. So from sklearn I'll import metrics. So in this cell we'll import all the required libraries, and in the next cell what we want to load the CSV data that we have so that we can start performing the data analysis, visualization and the machine learning models. So for that I'll open ChatGPT in a new tab. Here as you can see I've already opened ChatGPT, and what I'll search for, firstly I'll search for read CSV in pandas. So I'll just simply write read how to read CSV in pandas and we'll get the answer. So import pandas as this we have already done, and we have this function called read underscore CSV in pandas, so we can use that function and import the CSV files that we want to use in the project. So over here I have already searched for read CSV in pandas, and you can see the reply. To read a CSV file in pandas you can use read CSV function, and here it has given the coding example. So I'll directly copy this code from here and I'll paste it in the next cell, and here instead of file name.csv it is we have car space data.csv, and it will print the df.head. So let me remove this and just write df over here. So now you can see the data frame that we have. So the first column that we have is car name, then year of the car, and then selling price, present price of the car, then kilometers driven, fuel type, the seller type, transmission and owner, and finally these are all the 9 columns that we have inside our data set. Now let us try to get the basic statistics of this data. So what I'll search for is basic stats of data frame in pandas. So if I run this, then let us see what do we get. So the first method it is telling is we can use a describe method. So it will return things like count, mean, standard deviation, 25th percentile, 75th percentile, all that for the data. And so we'll try to use this function called describe, and let us wait for the final output that we are getting over here. One more thing, since this is a numerical measure, so describe will only give or run on the numerical values, not on the categorical values that we have in the dataset. So let me just copy this df.describe and I'll paste it over here. So it is giving count, mean, standard deviation, minimum, 25th and maximum value for all these columns, year, selling price. So the maximum selling price that we have inside this data set is 35, and the maximum kilometers driven is this one, and minimum is this one. So by using this describe you can get the basic idea about the data set that you are using. Now let us check the number of missing values that we have inside the data set. And before that, let me show you one more thing called df.info. By using this, you will see like you still have some kind of object type of data inside your data set, and some features are of numerical type like year, selling price, present price, kilometers driven, etc, etc. But features like if you see this seller type or fuel type, and since these are not numerical values, these are actual words written over here, so these are categorical features and you can see them fuel type, seller type in the object category. So we'll deal with them later. As of now, let us check the number of missing values in the dataset. So let me write how to get that. So check missing values in data frame in pandas. So let us see what is the response that we are getting. So it is telling to use the isNull method, and how it works it is also given over here. It will also give a basic code example. Since we already have the data frame or data set loaded, so we can just directly use the isNull method. So I'll just copy this. The isNull method provides a quick way to check for missing values in the data frame if you want to count the number of missing values in each. So the better is we can use the sum together. So isNull and sum together. So what I can do after this, I can write df dot isNull and I'll use the sum method on top of it. So here we are having 0 missing values in the dataset. That is actually very good. And now let us deal with the categorical data that we have. So we'll check the distribution of the categorical data. For this, we have one interesting method called value counts. So for that, what I can do is, first of all, we have fuel type, seller type, and transmission. For this, we have to check the distribution of values that we have. So firstly, I'll do df of, and let me copy this fuel type and I'll paste it over here. And the method is value underscore counts. So we have petrol 239, diesel 60 cars, and CNG 2 cars. Again, let me copy the same code and let me rerun it for seller type. So this time I'll go for seller type, and we have entries 195 entries for dealers and 106 for individual sellers, and finally we have transmission. So again I'll paste it, and instead of this fuel type I want to write transmission. So manual 261 and automatic 40. Now let us encode this data. So for encoding this data, what we can do, we can simply use this replace method, and let me show you one example on this. So if let's say we have 239 entries for petrol, 60 for diesel, and 2 for CNG. So instead of the word petrol, diesel, and CNG, because machine learning models do not understand textual data, so we have to encode it to numerical values. So wherever we have entries with petrol, we'll replace them with 0. For diesel, we'll replace it with 1, and for CNG, we'll replace it with 2. So instead of petrol over here, you will see 0. So let me change that, and same thing we'll do for seller type and transmission. So by encoding it to numerical values, the machine learning model will be able to understand that. So first of all, I need to use this replace method, and inside this replace method, the first column that I'm targeting is the fuel type. So what I'll do over here, I'll write the fuel type column. So fuel underscore type, and then 3 different categories that we have is petrol, diesel, and CNG. So again, I'll open a curly bracket, and first category I have is petrol, and this petrol should be encoded to 0. The next category that I have is diesel, and this should be encoded to 1. And third, CNG category, this should be encoded to 2. So CNG, and this should be encoded to 2. And the next thing that I want to do, this fuel type, this closing bracket should be present over here, and this whatever changes we want to make should be in place equal to true. So let me run this, and let me copy the same line, and we'll change this for seller type also. So instead of fuel, we have seller, and for seller we have 2 categories only. So let me remove this one, and instead of diesel, the second category is individual, and the first one is dealer. So for individual, we are highlighting it with 1, and dealer we are highlighting it with 0. So individual, and here we have a dealer. Again, let me run this cell, and we'll move to the third type of categorical feature, that is transmission. So over here we are using transmission, and manual is 0, automatic is 1. Again, we have two categories for transmission. And third, I want to delete this CNG because for transmission we only have two categories. Finally, let me show you how this DF looks like. So now as you can see, in fuel, seller and transmission, instead of petrol, diesel, dealer, individual, we are getting 0, 1 kind of encoded values that we have performed. So let us move to the next step. Let me split the data. So our X will be the independent features will be, we don't want to use the car name because it doesn't add any value, and the selling price will be in the Y column because that is the target variable. So let me do something like this. X is equal to df dot drop, and over here I want to drop car name, and second will be selling price, and I want to drop these two columns. So I'll write X is equal to 1 and Y will be df of selling underscore price. So now we have dependent and independent features defined. Now let me show you what we have inside X. So apart from car name and selling price, we have every other column. And then let me show you what we have inside Y. Yeah, so these are the selling prices that we have. Now the next step that we follow in the machine learning lifecycle is the train test split. So let us see how we can use train test split in we'll use sklearn. So it will give us the sample code and we'll directly use that and split the data. So we have already imported these libraries because we knew we would be needing that. And so this is the syntax, and xtrain, xtest, ytrain, ytest. So what it will do, it will basically, as you can see, the test size is given 0.2. So it will keep the 20% data for testing and 80% for training. So I'll copy this and we'll run it. So now we have our xtest, ytrain, xtrain, xtest, ytrain and ytest. And now we'll do the model training. So first of all, we need to train a linear regression in sklearn. So again, let us see how we can use that linear regression model in sklearn. So let us see the reply, and we want the syntax. So linear regression again is a machine learning model that we use to perform regression. So we have to copy this code, model equal to linear regression and model dot fit x and y. But instead of x and y, we are going to train the model on xtrain and ytrain as discussed. So I'll copy paste it over here, and this will be xtrain and this will be ytrain, and I'll run this model. The fit method is already running, and let us store the predictions that are made by this model into a different data. So I'll make this variable called pred for storing predictions, and I'll use model dot predict, and I'll use xtest. And so the predictions that are made by this model on the testing data are stored over here. And if I compare this with what we have in ytest, so these are the actual predictions. So now let us visualize the actual and predicted prices. So what we'll do, we'll make a scatter plot. So plt dot scatter, and here the first thing I want to do is ytest, and the second I want to make predictions. I'll give my x label be the actual price, and plt dot y label will be predicted price, and then I'll do plt dot show. So this will make a scatter plot. On x-axis we have actual price and on y-axis we have predicted price. And finally, let us check the error that we are getting. So mean absolute error. So matrix. Let me get the syntax from here. Mean absolute error sklearn matrix. So the MA is a common metric to evaluate the performance of regression models. So let us see how we can use that. We've already got the model and we already have the predictions. So we just have to copy the syntax for mean absolute error. So matrix dot mean absolute error. Okay, let me copy this and I'll paste it over here. But since we have to use matrix dot mean absolute error, okay, why pred? We are using the variable called pred only. So the mean absolute error is 1.22. So our model is making predictions that are off by 1.22 points according to the dataset, which is actually a pretty decent performance for this model. So I hope you are clear with the entire logic of how we implemented this project and how you can use ChatGPT to increase the coding speed and efficiency. Thank you for watching. Now let's move to the next video. Hello and welcome to the introduction video of the wine quality prediction machine learning project. In this video, you will get a basic overview and an idea about the project workflow that we're going to follow, and finally the ultimate objective and the target that we're going to predict using by building this project. So these are some of the features that we'll use to predict the quality of the wine. Again, as we are trying to predict different classes of the wine, whether this is good or bad, so this will fall under the classification problem of machine learning. And we have different features like total sulfur dioxide, chlorides, volatile acid, free sulfur dioxide, sulfates, fixed acidity density, acidyl sugar, etc. etc. Here also you can see the clear-cut list of the dataset features. Like basically the aim of the project will be by using the details about the wine like the pH, alcohol percentage, volatile acidity, chlorides, sulfur dioxide, residual sugar, density, etc. etc. We are trying to predict the quality of the wine by building a machine learning model that ChatGPT will help us to build it in a very quick and efficient manner. So basically we're trying to see all that in by this project. Now let's understand the workflow that we are going to follow. So this is a typical workflow that this is the basically industry standard that is used for every data science and machine learning project. So you start by the process of acquisition of the data. For the aim of this project, you will have a CSV dataset in your resources section. You can download that and follow along. Then we'll have some data pre-processing part like feature encoding or cleaning the data, preparing the data so that the machine learning model is able to train perfectly. Then once we have cleaned and pre-processed the data according to our requirement, then we'll move to the training part of the model and we'll train the model with let's say 70 to 80% of the data, and rest 20-30% of the data will keep for testing and evaluating the performance of that machine learning model. So if we are not satisfied with the accuracy that we are receiving, then we can tweak some hyperparameters or change some or data pre-processing steps that we have done. So once we are satisfied with the accuracy, then we'll build a kind of predictor system that when we give different features like residual sugar, alcohol, density, chlorides of the wine, we'll get the quality of that wine. So this will be the ultimate goal of the project. I hope you are clear with the workflow and have a decent idea of what we are trying to build over here. So let's move to the coding part. Hello and welcome to the next video in the course of ChatGPT for data science and machine learning. In this video, we'll see the coding implementation of the wine quality prediction project. Firstly, let us import all the required libraries that we'll need. So import numpy as np. Then I need import pandas as pd. And for doing some data visualization, we'll be working with matplotlib and seaborn. So let us import that. Import matplotlib dot pyplot as plt, and I'll import seaborn as SNS. Then since this is a classification problem, so we are going to use this algorithm called random forest classifier. So basically we're trying to classify whether the quality of wine is good or bad. So we are treating it as a binary classification problem. So I'll import the random forest classifier algorithm from sklearn dot ensemble. I'll import random forest classifier, and then to evaluate the performance of the model we'll use a metric called accuracy. So for that I will import from sklearn dot metrics. It is metrics. I'll import accuracy score. So this will be the evaluation result. And finally, since this is a supervised learning problem, so we'll train the model on 80% of the data, and rest 20% will use for the testing purpose. So for performing the train test split operation, I need to import one more thing. That is the from sklearn.model selection, I have to import train test split. So let me import that from sklearn.model selection. I'll import train test split. Now that is finally done. Now let us read the CSV file inside our pandas data frame. So you will find the CSV file in your resources section. I'll open this ChatGPT, and let's say I want to read CSV in pandas. How can I do that? So there's this function called read underscore CSV, and we have to give the path. So I'll just simply copy this entire code, and I've already imported pandas in the first cell. So I'll run this, and instead of, since this file is present in the same location where I'm running this Jupyter notebook, so I just have to give red. Okay, what was the name of the file? That was wine quality hyphen red.csv. Instead of this df.head, I can just simply print this entire data frame in the next cell, and this is the data that we have. So we have different features like fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, and finally the quality of wine. So all these are numerical features. Before that, let us check whether do we have any kind of null values in the data or not, and let us also check the shape of the data set. So I'll do df dot shape to check the shape. We have 1599 rows and 12 columns. And how do we check null values in data frame pandas? So it will tell us to use some methods that we can use. So is null dot sum. So let me copy this, and here let me paste. So as you can see, we have 0 null values that are present inside the dataset, and let us understand some basic statistical measures of the dataset. So for that, we have this method called describe. So I'll run df dot describe, and it will give us basic statistical measures like count, mean, median, standard deviation, what is the value at 75th percentile, 50th percentile, minimum and maximum value, about different features of the dataset. So the maximum fixed acidity value that we have in the dataset is 15.9, and minimum citric acid content that we have is 0.00. So these are basic statistical attributes that you can use. Now let us do some visualizations. So what we'll do, we'll basically try to find number of values that we have for each quality. So we are going to use the cat plot from Seaborn, and let us see how do we plot that. So cat plot Seaborn, and let us see what do we have in the answer. So cat plot is a function in the Seaborn library that allows to create various categorical plots. It can be used to plot categorical data with one or more variables that can be split by different user columns. So over here, what we're going to do, so I'll copy the syntax, and I'll copy this, and I'll paste it over here. And in the X, instead of day, in that example, we have quality, the quality of the wine. And in the Y, as of now, we won't be putting anything. and in data we have df, and over here we'll add kind that we are trying to plot is count. So let me run this cell, and this is the kind of plot that we have. So we have maximum 5 and 6, and since this quality is our target variable, so we have to figure out a way to make the binary predictions out of these. So at what quality level will predict whether the wine is good, and on at what level we'll see that the wine is not good. So we'll see how we can address that. Now what else we can do is basically we can plot different features against the quality to get the better understanding of how the data is distributed. So let us try to plot a citric acid versus quality. So this time let me make a bar plot. So again the syntax will be very common to this that we already got from ChatGPT. Instead of cat plot we'll be using a bar plot. So I'll directly type SNS dot bar plot, and here again in X we will be having quality, and in Y, since we are plotting this against citric acid, so citric acid, and finally the data that we're going to use is from the data frame. Okay, here we are getting one error. Citric acid is not able to find. Okay, citric acid, that was a spelling error. Yeah, so this is the plot that we are getting. So these were some basic visualizations that you can develop to that you can make to get a better understanding about the data. Let's find the correlations that we have over here. So how do we find correlation in pandas? Let us search how to find correlation in pandas. So to find correlation in pandas, we have this method called cor method. So let us see how we can use this method. So what I'll do, df.cor. Okay. So I'll do this thing, correlation, that is equal to df.cor, and all the correlations will be stored in this variable called correlation, and we'll construct a heat map using SNS or Seaborn. So I'll plot SNS heat map, and over here I want to plot these correlations in a heat map, so I'll plot them over here. Then these are some different arguments, optional arguments that we are giving to get a better visualization of the heat map. And then I have square, that will be true, and fmt, that is equal to dot 1f, and finally we want annotations, so I'll give annot equal to true and annot underscore kws. This will be inside the curly bracket, and the size I have is 8, and then finally CMap will be let's use blue. So this is the final heat map of different correlations that we have among different features in the dataset. So as you can see, we have this 0.7. So citric acid and fixed acidity have a very high correlation, and so these are basically different interpretations that you can take out, like density and alcohol are negatively correlated. Like more the alcohol content, less will be the density, and which is minus 0.5. So if you are having correlation that is above 0.5 or minus 0.5, that is basically just strongly correlated. If you have a positive value, that means it's a positive correlation. If one feature increases, the other feature will also increase. And if you have a negative value with a strong correlation, that means if one feature increases, the other feature will decrease. Now let us perform some data pre-processing. So we'll separate the target from the attributes. The target will be quality. So we are trying to predict the quality of the wine. So that will be a target variable. So in the X, which is all our independent features, we do not have the target. So we'll drop it from the X. So I'll do X equal to TF dot drop. And over here, I'll drop the quality column from this X is equal to 1. And now we'll perform label binarization on the Y, which is our target. So I'll do Y, which is equal to df of quality, and I'll apply a lambda function over here. This will be lambda. I'll create this Y value, which will be 1 if Y value is greater than 7. If this is the case, else it will be 0. So this will be our Y. So let us see what do we have inside Y. Now we'll be having 0 and 1 inside the Y. So based on this quality that we had, if we have greater than 7, then the wine quality is good, that is actually 1. And if the value is less than 7, then it is 0. So this is what we are classifying it as a binary classification problem. I hope you are clear till this part. Now let's perform the train test split. So let me create a new chat over here, and I'll ask for train test split in pandas. We'll directly get the syntax. How do we perform this? So we already imported this library, and it will split it into 80-20 ratio. Now you can use these two training data sets for training and testing. We also have one more efficient way that we can use this. So instead of creating just two train and test, we'll create X train, X test, Y train and Y test. I'll show you another way also. So we'll do X train, and then we have X test, then we have Y train and Y test. Again, this part we can at least just simply copy. So we'll do train test split, and we'll give, instead of df, because we want to create 4, so instead of df we'll give X and Y. So over here, instead of df, I'll give X comma Y, and the test size is equal to 0.2, and this is any random state that you want to select. Now let us train our model. So first of all, I'll make this model variable, and I have random forest classifier over here. Then I'll do model dot fit, and this model will be trained on the training dataset X train and Y train. So model will be trained on this training dataset, and let us make some predictions that will be stored inside the spread model dot predict, and let us test it on the X test dataset. And finally, let us try to get the accuracy. So I have this accuracy score. We have Y test and pred. So we're getting a 98.43% accuracy, which is actually a very decent accuracy. So this is how you can use ChatGPT to quickly implement your data science and machine learning project. I hope you are clear with the entire life cycle of the machine learning project that we covered in the video. Thank you for watching. Now let's move to the next video. Hello and welcome to the next video in the course of ChatGPT for data science and machine learning. This is the project introduction video on customer segmentation using k-means clustering algorithm. Up till now we have discussed two projects. First one was car price prediction, and then the wine quality prediction. Those two projects come under the supervised machine learning category. One was the regression project and second one was the classification. This k-means clustering is a unsupervised learning problem. So let us see how we can deal with it and solve this problem. Firstly, let us understand the problem statement that we are trying to solve over here. So we want to identify the potential customer base for selling our product. And then how will we solve it? By implementing clustering algorithm to group the customer base into different segments or different clusters. And then once we are done with for creating clusters, then we can sell the product to the identified customer group. Let's say we have a large database of 100 consumers, and we have the data about their spending habits, income, their gender, and credit score, etc. etc. So based on this data, we created few different clusters. Let's say a cluster A has the people with very lavish spending habits, and they have high credit score. So we can probably sell those kind of products to customers that are present in the cluster A. Let's say we have a cluster C with people that are having relatively low income and low spending score. So then we can sell those kind of products to customers in the cluster C. So by segregating our customers, we can sell more and relevant products to those customers. Now let us understand the features that we have inside our dataset. The first one is the customer ID. By using this, we can identify the different unique customers that we have in the dataset. Next, we have the gender, age, annual income of that person, and spending score. So based on these features, we'll create different clusters on our data. Let us understand the project workflow. So we'll get the data, we'll prepare the data, then we'll train the model, and then finally we'll make different clusters. So this is a typical machine learning workflow that we have already seen. I hope you are clear with the problem statement that we are trying to solve in this project. Thank you for watching. Now let's move to the coding part. Hello and welcome to the next video in the course of ChatGPT for data science and machine learning. In this video, we'll do the coding implementation of customer segmentation project using k-means clustering algorithm. So first of all, let me tell you a basic difference between the projects that we have done till now and this one. So this is the first project that we're going to do on an unsupervised machine learning technique. So if you want to understand better like what is supervised machine learning and what is unsupervised machine learning, let us just go to the chat GPT and we'll search for supervised versus unsupervised machine learning. So what basically in unsupervised machine learning, we used to have a training data set on which we used to train the model, and then we used to have a test data set on which we will evaluate the performance of the model. But in supervised machine learning, we have the labeled data. So here, as you can read the definition, supervised and unsupervised learnings are the two main categories of machine learning. Supervised learning is a type of machine learning in which the algorithm is trained using labeled data. So that is very important thing. This means that data is already classified or categorized and the algorithm learns to make predictions based on the labeled data. In supervised learning model for image classification, the algorithm will be given a set of images with labeled categories, example cat, dog, bird, and it would learn to recognize the features that differentiate each category. And let us see what do we have for unsupervised learning. On the other hand, this is a type of machine learning in which algorithm is trained on unlabeled data. This means that the data has no pre-assigned labels and the algorithm learns to find patterns and relationships within the data. In unsupervised learning model for clustering, the algorithm would group similar data points together based on the similarities. So very briefly, and you can understand with these quick pointers, in supervised learning technique, you basically solve two different type of problems. That is the regression and the classification problem. Like you have seen the examples. In regression problem, you just train the model and it will predict the value. And in classification model, it will make classification problems like the code that we did in the last video, the wine quality, whether the wine quality is good or bad. But in this video that we are going to do is unsupervised problem, that is clustering. So basically we are not training or labeling the data, we just simply finding the patterns in the already that are existing in the data set that we already have. So we will basically make the clusters of different group of customers that we have in the data set. So with that, let us start. First of all, I need to read CSV in Panda, so I'll quickly search for that, and then we'll also need to check null values in Pandas. So I'll quickly copy the code snippets. First of all, I need to copy this one import pandas as pd, and I'll paste it over here. And the file name we have is mall underscore customers dot csv. So this is the file that we have. And finally we want to check null values, whether we have null values present in the file or not. So it says file not found. Let us see. Mall customers dot csv. I'll copy this name and I'll paste it over here. Yeah, so now this works, and I'll see the data frame that we have. So basically inside this data we have customer ID, gender, age of the customer, annual income, and spending score. So based on all the attributes that we are given for different customers, we'll have to categorize them into different clusters, whether let's say a person with a high income and a high spending score will be placed in cluster 1, and a person with low income and low spending score will be placed in, let's say, cluster number 4. So based on different categories of the consumers that the company has, it can easily target different audience that it want, and it can sell relevant products to them, which will eventually boost their earnings. So this is the ultimate aim of the problem that we're trying to solve. And now let me run this print df.isn't.sum, and so all the rows, all the columns do not have any null values. Now let us choose the annual income and spending score column, because annual income and spending score are probably the two main factors on which we can categorize customers into different category. A person with a high income and high spending score has is more probable that he or she will buy a higher range product. So let us separate it. So I'll make the x that is equal to df, and I'm going to use this iloc function over here, and inside this I'm going to select all rows but only column number 3 and 4, and I want values for all of them. So let us see what do we have inside x. So now we have annual income and spending score for all the data points that we have inside the column. Now this what we want to do is we want to know the ideal number of clusters. So how many groups should we categorize the entire data into? For that we have this thing called elbow method that will plot a graph, and based on the elbow point of the graph we will be able to identify the most optimum number of clusters. This is a very common technique that is frequently used in k-means algorithm. So let us study about that. Elbow method k-means. So let us see what do we get in reply from ChatGPT. It's taking a little long. So the elbow method is a technique that is used to determine the optimal number of clusters in k-means clustering algorithm. So basically what it does, it works by plotting the sum of squared distances between each data point and its nearest cluster for the different values of k. K here is the number of clusters that we're trying to make. So here they are also giving one code snippet that we can implement in Python. So again, for that we need to import these libraries that we have not imported already. So let me copy this, and until the enter snippet is printing in ChatGPT, let me run this cell. And next they are giving the entire code to plot, and let it complete, and then we'll copy the code. So in the code, we first load the data into a pandas data frame that we already have df, and we create an empty list SSE to store the SSE values for each value of k. That will be the number of clusters that we are trying to running. Now the way to look at the result is that on the entire graph we have to find the elbow point, and the number that is present on the elbow point will be the ideal or the optimum number of clusters that we are going to use. So let it complete. Till that, let me copy this code over here. And what is the result that we are getting? Again, the elbow method is, as it is saying, the elbow method is just one technique for selecting k, and other methods such as cell hook analysis and others can be used. But for this, let us use the elbow method. So let me copy this, and let us see what is the result that we are getting over here. 1 to 11 df. Yeah, df is the same name, and let us run. So we are getting an error. Okay, but here we don't have to use the entire df. We have to just use the x that we have created, because x has both spending score and income of that person. So now, as you can see, we are getting the ideal graph. And here, if you observe this point very carefully, which is actually between 4 and 6, so it is 0 0.5. So this is the elbow point of the curve. So basically the ideal clusters that we should make is number, optimal number of clusters will be 5. So now let's proceed by training the k-means clustering model. So what I'll do this k-means, which is equal to k-means, and here for training this model we have to give n clusters. So basically the clusters that we wanted to make for us, and by elbow method we derived that 5 is the optimum number of clusters. So that's why for this argument we'll give 5, and I'll give init will be k means plus plus, and over here let me give a random state of, let's say, 1. And so k-means is not defined, so we have to import this k-means. I think we already imported this from sklearn.cluster. We already imported this. But it is saying k-means is not defined. Let us see what is the issue. Okay, so this thing we have to use capital M over here. Yeah, now this works perfectly. Now let us return a label for each data point based on its cluster. So I will create a y, and then I'll do this k-means dot fit, and I'll write fit underscore predict method, and I'll make predictions for this x, and that will be stored into y. And let us see now what do we have inside y. So y has all the cluster number predictions that we have done. So from 0 to 4, that means totally we have 5 clusters: 0, 1, 2, 3, 4. So total 5 clusters we have. Now let us visualize all the clusters that we have made. So I'll write the code for visualizing it. First of all, let me make a plt.figure. So plt.figure, this will be let's use the fig size and make it for 9,9, and then I'll use a scatter plot, and I'll make 5 different scatter plots on a single graph with different colors. So what we can do is, so I'll make just write this line of code, plt.scatter, and over here what I want to do is x, and for that y what we have done is 0, 0, and again the next that we have to do is x, y, and this is equal to 0, 1, and then I'll do s is equal to 50, and the color, let us use green over here. I have to use single quotes for green, and let me label this as cluster 1. So this is C1. I'll copy this entire statement, and then the next thing that I want to change is over here, instead of 0, 0, I'll make 1, 0, and this will become 1, 1, and here I'll have to use a different color. So let's use red, and let's name this cluster 2. For the third one, what I want to do is 2, 0, and finally over here it will be 2, 1, and let's use yellow color for this, and I'll label it as third cluster, and finally the next will be 3, 0, and this will be 3, 1, and I'll use let's say blue color for this, and I'll name this as cluster number 4. And finally the fifth one will be, which is by index number, this is 4, and over here this is also 4, and let us use violet color over here, and let's name it C5, and we will plot all the centroids over here. So plt dot scatter, and I want to do the centered point of the k-means algorithm. So k means dot cluster underscore centers, and this will be colon comma 0 for all, and k means dot cluster underscore centers underscore, and this will be all comma 1, and s will be equal to 100, and let's use cyan color for this, and I'll label as centroids. And now this is done. Let us give the title for the plot. So plt dot title, and the plot is about customer groups that we have created. So customer groups, and the x label will be on the x-axis we have annual income, and finally plt dot y label we have the other feature that we took, that is spending score. And finally, to see the plot, I'll write plt dot show. So yeah, this is the plot that we are getting. These are all the cluster centers, and these are 5 different clusters that we have made over here. On the y-axis we have spending score, and on the x-axis we have annual income. This is the complete result of the project that we have done. I hope you are clear with all the steps discussed in the video. Thank you for watching. Now let's move to the next one.